Beneath the soft layers of skin and muscle, within the quiet interior of every human being, lies a structure both ancient and alive. The human skeleton, though it seems so still and unmoving, is in truth a living framework, one that supports every action, every breath, and every gesture. It is not merely a collection of bones, but a network of tissues, fluids, and connective elements that work together in perfect, silent coordination. When we look upon a skeleton in a museum, bleached and lifeless, it is easy to forget that our own bones are far from inert. They grow, repair, and adapt throughout life. They are in a state of constant conversation with the rest of the body, responding to its needs with a quiet diligence that goes unnoticed in the rush of daily living. If one could slow time and listen carefully, the body would tell its story through the subtle shifting of joints, the soft stretch of ligaments, and the rhythmic renewal of bone. Every structure we see in the skeleton has a purpose, every curve and hollow a meaning. The bones are shaped by motion, sculpted by the pull of muscles and the demands of gravity. They are not rigid as stone, but resilient, alive with blood vessels that bring nourishment and carry away waste. This living architecture forms the foundation upon which all other systems depend. It shields delicate organs, anchors powerful muscles, and provides the very form that allows us to move through the world with balance and grace. The skeleton begins as something much softer. In the earliest stages of life, before birth, the body's framework is made largely of cartilage, a flexible, rubbery tissue that bends and yields easily. As the child grows, minerals such as calcium and phosphorus begin to accumulate, gradually transforming this pliable matrix into the sturdy bone of adulthood. Yet, even when hardened, bone never loses its vitality. Deep inside, cells are always at work, some building, some breaking down, maintaining a delicate balance that keeps the skeleton both strong and adaptable. It is a constant cycle of renewal, as if the body were quietly tending to its foundation, repairing what time and motion wear away. The human skeleton is composed of 206 bones. Though this number can vary slightly from person to person, some are large and heavy, like the femur and the thigh. Others are minute and intricate, like the tiny ossicles of the inner ear that help convey sound. Together, they create a structure that supports about 1/5 of our total body mass. These bones are arranged in two main divisions: the axial skeleton, which includes the skull, spine, and rib cage, forming the central pillar of the body, and the appendicular skeleton, which includes the limbs and their supporting girdles. The axial skeleton provides protection and stability, while the appendicular skeleton gives mobility and reach. It is within this living framework that the story of motion begins. Bones by themselves cannot move, need the assistance of joints, the places where two or more bones meet. The joints are the hinges, the pivots, the sliding planes that transform the body from a static structure into a dynamic, living instrument. Through them, we bend, rotate, extend, and grasp. Every dance, every quiet stretch of the hand, every rise and fall of the chest is guided by their subtle cooperation. Without them, we would be motionless statues shaped, but not alive in movement. Yet even stillness is supported by them. The quiet act of standing upright, or holding a single posture in balance, calls upon countless joints to work together in micro-adjustments, so fine they pass below the threshold of our awareness. Each vertebra in the spine moves only slightly, but the sum of these tiny motions allows the whole body to remain upright, flexible, and responsive. Beneath the surface, it is a choreography of bone, cartilage, and muscle, a slow, silent dance that continues as long as life does. The strength of bone lies in its complex structure. Though it feels solid to the touch, it is composed of two main types of tissue: compact bone and spongy bone. Compact bone forms the hard outer shell, dense and strong, while spongy bone, found mainly at the ends of long bones and within the interior of others, is light and porous, filled with marrow and delicate struts called trabeculae. This combination allows the skeleton to be both sturdy and light enough for movement. The marrow itself, red in the young, yellow with age, is a thriving factory of blood cells, continuously renewing the body's supply. Even in rest, the bones are working, quietly sustaining life in ways unseen. Each bone is a study in balance. Long bones, such as the humerus or femur, are shaped for leverage and support. Flat bones, like the skull and scapula, are designed for protection and attachment. Irregular bones, like the vertebrae, combine elements of both, but all share the same living essence. They are covered by a thin, fibrous membrane known as the periosteum, rich in nerves and blood vessels. This sensitive layer feeds the bone beneath, helps in repair, and anchors the tendons that attach muscle to bone. In this way, bone becomes part of a greater whole, not an isolated structure, but an active participant in the body's endless cycle of growth and response. When you lift your arm, dozens of bones and joints act together in seamless unison. The shoulder, elbow, and wrist all contribute their specific movements, while the smaller bones of the hand provide the fine control. Each joint allows a particular range of motion and is shaped for its purpose. Some are locked firmly in place, offering protection and stability, while others are marvels of mobility, designed for sweeping arcs and rotations. The shape of each bone determines its role, and its role defines its form, a principle as true in anatomy as in art. In moments of motion, it can be easy to overlook the stillness that underlies to it, yet every motion begins in balance, in the steady alignment of the skeleton. The spine bears the weight of the head and trunk. The pelvis distributes that weight to the legs. The feet, with their arches of bone and ligament, absorb and release the force of each step. Every part supports another, and the entire structure works as one continuous whole. It is a living architecture shaped not just by evolution, but by every step we have taken since childhood. In the calm of rest, this framework continues its quiet labor. The weight of the day may ease, but gravity never stops, and the bones remain faithful in their duty. Calcium flows in and out, responding to hormonal signals that maintain balance in the blood. Cells known as osteoclasts dissolve small areas of bone, while others, called osteoblasts, build new tissue in its place. This ongoing exchange ensures that the skeleton remains strong, responsive, and ever adapting to the life it carries. When one pauses to consider this, there is a quiet beauty in it. The body is not a static object, but a living ecosystem of renewal. Even as we sleep, our bones are listening to movement, to pressure, to need. They remodel themselves in response to what we do each day. A dancer's bones grow denser in response to impact. A swimmer's joints maintain a supple freedom from fluid motion. The skeleton remembers how we live, shaping itself around the story of our habits. This is why the human skeleton is far more than a framework of support. It is a record of life itself. It tells of growth, of adaptation, of endurance. The lines of each joint, the curves of each bone, are written in response to the movements and stresses of a lifetime. When we think of anatomy, we often think of parts, bones, muscles, joints as separate things. Yet within the body, they are inseparable. The skeleton does not exist without the muscles that move it, nor do the joints function without the connective tissues that hold them together. In stillness now, imagine this framework within you, the long columns of the legs, the curved vault of the ribs, the delicate bridge of the collarbones. Imagine the weight they bear so quietly each day, the balance they keep without effort. Beneath the surface of skin and muscle, Your bones hold you upright in perfect equilibrium. They carry you through the world with a steadiness that asks for no recognition. And yet, within their quiet, lies the most fundamental truth of human life, that we are built to move, to stand, to grow, and to rest. The living framework of the skeleton is both our foundation and our freedom. It gives us the strength to endure and the grace to move gently through the world. It supports our days, our gestures, and our sleep, enduring, adaptable, and endlessly alive. 2. The skeleton's silent harmony. When we think of harmony, we often imagine music's soft tones blending together, no single note dominating, each one essential to the larger sound. The human skeleton is much the same, an orchestration of form and function where every bone, joint, and connective strand plays its quiet part. Together, they create the balance that allows us to stand, to move, to rest, and to remain whole. Beneath the skin's warmth and the muscles' motion lies this silent composition, unceasing in its rhythm, unbroken in its purpose. The skeleton does not act alone. It works in concert with the muscles that pull upon it, the tendons that anchor those muscles, and the ligaments that steady each joint. Every motion, no matter how small, is the result of their cooperation. When you reach for something, the bones of your arm provide the structure. The muscles supply the force, the joints permit the motion, and the nerves guide them all in smooth unison. This cooperation is effortless only because of the body's deep design, a design refined through millennia of adaptation and balance. At its center stands the spine, the column of life that carries both strength and flexibility. Composed of 33 vertebrae, the spinal column curves gently like a slow wave. This curvature is not accidental. It is what allows the spine to absorb shock and to distribute weight evenly. It bends, but it does not break. Within this central pillar, the spinal cord rests protected, carrying messages from the brain to every corner of the body. Around it, the muscles of the back and abdomen hold a delicate tension, keeping the body upright while still allowing graceful motion. This equilibrium between rigidity and softness is a central theme in the skeleton's harmony. The ribs form another layer of balance, a cage that is not quite a cage. They encircle the chest to protect the lungs and heart, yet they rise and fall with every breath. Their joints, with the spine and sternum, are flexible enough to allow expansion, so that with each inhale, the rib cage opens gently, and with each exhale, it settles back into place. The motion is so fluid that it often goes unnoticed, yet it is constant throughout life. The skeletal system thus moves even in rest, performing its subtle duties with quiet regularity. The limbs are like instruments tuned for different roles. The upper limbs, the shoulders, arms, and hands are built for range and precision. The shoulder girdle, made of the clavicle and scapula, forms a loose connection with the rib cage, granting the arm extraordinary mobility. The lower limbs, the hips, legs, and feet are built for stability and support. The knees and ankles, though mobile, are engineered to bear immense pressure, their shapes distributing the forces of walking and standing across their surfaces. The bones of the feet, 26 in each, create a series of arches that flex with each step, absorbing impact like natural springs. It is this cooperation between upper and lower, between rigidity and movement, that defines the skeleton's harmony. Every part has its counterbalance. Where one structure allows freedom, another ensures control. The hip joint provides a wide range of motion, yet it is deeply seated in its socket to prevent dislocation. The shoulder sacrifices some stability for greater flexibility, allowing the arm to move in nearly every direction. The design of the skeleton is one of constant negotiation, a dialogue between safety and motion, between firmness and flow. In the quiet of the night, the skeleton still responds to the world. Even at rest, Tiny adjustments occur to maintain posture. If you shift in your sleep, the joints adapt to the new position, the muscles ease or tighten, and the bones align anew. Gravity is always present, and the skeleton is always listening to it. The body's weight flows downward through the vertebral column, across the pelvis, and into the legs. At each step, this weight transfers from one side to the other in a rhythm so fluid it feels natural. The harmony of this design lies in how effortlessly it accommodates motion without losing balance. Each joint, no matter its size, contributes to the overall equilibrium. In the toes, they help maintain balance as you walk. The jaw joint, though small, plays a role not just in chewing but in speech and expression. The larger joints, the hips, knees, and shoulders, serve as the body's major fulcrums, converting muscle power into smooth mechanical motion. Each movement flows through multiple joints, muscles, and bones, working as one continuous system. Within this system, the materials themselves are harmonized. Bone is not only strong but slightly elastic, able to absorb shock without fracturing. Cartilage cushions the meeting points between bones, preventing friction and distributing forces evenly. Synovial fluid, clear and viscous, flows through the spaces within joints, reducing resistance so that motion remains silent and smooth. Ligaments provide restraint, preventing movement from exceeding safe limits, while tendons transmit muscular energy to bone. Together, they create a dynamic balance, flexibility within boundaries, motion within stability. If we could observe the skeleton in motion without its surrounding tissues, we would see an astonishing complexity hidden beneath the surface. As one leg lifts, the pelvis tilts, the spine curves slightly to counterbalance, and the shoulders adjust in sympathy. The body's architecture behaves less like a rigid structure and more like a suspension bridge, each part bearing and redistributing weight in response to the rest. This is why human motion appears so fluid. Every gesture is a wave of balance flowing through the skeleton from one end to the other. The curvature of the clavicle allows it to act like a strut, holding the shoulder away from the chest to maximize reach. The long, curved shape of the ribs accommodates the rhythmic motion of breathing. The arches of the foot transform rigid bone into a responsive spring. The spine's natural S-curve is a triumph of design, maintaining posture while allowing motion in multiple planes. None of these features exist in isolation. They all depend on one another to maintain the body's steady equilibrium. This harmony is also reflected in the relationship between movement and rest. The same structures that allow motion must also permit stillness. When standing still, countless muscles remain partially engaged, providing tone without tension. The joints remain aligned, the weight evenly distributed, and the bones quietly bearing the load. The skeleton's design allows this sustained balance with minimal effort, conserving energy through geometry and alignment rather than brute strength. Across the span of life, this harmony evolves. In youth, the bones are still forming, soft and pliable, the joints wide and fluid. In adulthood, strength and flexibility reach their peak, perfectly balanced. With age, the materials shift again, the bones grow denser or thinner in response to use. The cartilage wears gently, the ligaments adapt. The harmony does not disappear. It simply changes key, moving into a slower rhythm that matches the pace of experience. Even then, the body continues to respond, adjusting posture and movement patterns to maintain stability and grace. It is remarkable to consider that this entire system operates without conscious thought. You do not think about aligning your spine or distributing your weight as you walk. The body manages it for you, guided by sensory feedback and muscular coordination. This silent partnership between the bones, joints, and nervous system keeps you upright, mobile, and safe. It is an ancient intelligence built into the structure itself, the wisdom of evolution written in the curve of each bone and the glide of every joint. In the stillness of evening, when the body begins to rest, this harmony continues quietly beneath awareness. The heart slows, the breath deepens, and the skeleton releases the day's tension. The joints soften into their resting angles, the muscles lengthen, and the spine settles into its natural curve. The body, once in motion, now finds repose. Yet, even in that repose, the skeleton remains alive and aware, ready to rise again and move with the same ease and precision that define its design. To understand the skeleton is to recognize the harmony that sustains every moment of life. It is the balance between support and movement, between the need to stand firm and the desire to reach outward. Within that balance lies the quiet beauty of the human form, a harmony so perfect it often goes unnoticed. Yet it carries us through every step, every breath, every hour of our existence. 3. The nature of bone. To understand the human skeleton, one must look closely at the very substance that composes it, bone. It is easy to imagine bone as something rigid and lifeless, a material that belongs to the domain of fossils and anatomy charts. Yet within the living body, bone is anything but dead. It is a vibrant, responsive tissue, constantly changing in rhythm with the life it supports. Each bone is a miniature ecosystem, a community of cells and minerals, of fibers and fluids, working together in an elegant cycle of creation and renewal. It carries strength not by being unyielding, but by balancing firmness with subtle flexibility, endurance with renewal. The story of bone begins in the earliest stages of life, long before birth, within the growing embryo. The framework of the future skeleton starts as cartilage, soft, translucent, and easily shaped. This early tissue provides a model, a scaffold upon which true bone will later form. As the weeks pass, cells known as osteoblasts begin their careful work, depositing minerals and hardening the structure. This transformation is called ossification, and it continues throughout childhood as the soft cartilage models gradually turn into strong, mineralized bone. Even after this process seems complete, small zones of cartilage remain at the ends of long bones, the growth plates, which allow the skeleton to lengthen as the child grows. Only when growth ceases do these plates close, fusing into solid bone. Though we often imagine bones as dry and chalky, within the living body they are moist and richly supplied with blood. Arteries wind their way through channels within the hard tissue, bringing oxygen and nutrients to bone cells, while veins carry waste products away. Inside the central cavities of many bones lies bone marrow, a soft, spongy tissue that produces blood cells. In the red marrow of children and in certain bones of adults, such as the sternum, ribs, pelvis, and vertebrae, new red blood cells are born every second, ensuring that the blood remains fresh and full of oxygen. In this way, the skeleton is not simply a framework but also a life-giving organ, intimately tied to the body's vitality. If one were to look inside a bone, it would not appear solid throughout. Bone is built from two types of tissue that work in perfect partnership. The outer layer, known as compact bone, is dense and strong, providing structure and protection. It forms the smooth, white surface we see in skeletal diagrams. Beneath it lies spongy bone, lighter, more porous, and arranged in delicate lattice-like patterns, called trabeculae. This inner network gives strength without unnecessary weight. Its tiny struts are positioned precisely along lines of stress, like the beams of an architect's design, providing maximum support with minimal material. It is this remarkable geometry that allows the bones to bear weight and resist fracture while remaining light enough for movement. Bone is primarily composed of two elements, collagen and calcium phosphate. Collagen, a tough, flexible protein, gives bone its slight elasticity and resistance to tension. Calcium phosphate, a crystalline mineral, provides hardness and compressive strength. Together, These two substances create a composite material more durable than either alone. If bone were made only of collagen, it would bend too easily. If made only of mineral, it would shatter like glass. Nature has blended them in just the right proportions to create something strong yet resilient, enduring yet alive. On the microscopic level, bone is alive with activity. Within its structure dwell several types of specialized cells, each with its distinct role. Osteoblasts are the builders, forming new bone tissue and depositing the mineral matrix. Osteocytes, once osteoblasts that have become embedded in the very bone they created, serve as caretakers, sensing stress and signaling when repairs are needed. Osteoclasts are the recyclers, breaking down old or damaged bone so that fresh tissue can take its place. This process, known as remodeling, continues throughout life. It ensures that bones remain strong and adaptable, responding to the pressures placed upon them. Even in adulthood, around 10% of the skeleton is renewed each year, a quiet rhythm of destruction and renewal that keeps the structure young at heart. The adaptability of bone is one of its most remarkable qualities. When a person engages in regular physical activity, walking, lifting, or simply moving against gravity, bones respond by becoming denser and stronger. The mechanical stress stimulates osteoblasts to deposit more minerals, reinforcing the bone's structure. Conversely, when bones are not used, such as during prolonged bed rest or in the weightlessness of space, they begin to lose density. The body, ever efficient, reclaims unused material for other purposes. In this way, bone reflects the story of its owner's life, strengthening with effort, weakening with neglect, and changing shape subtly in response to every movement and posture. Each bone in the body has its own form and function, shaped perfectly for the role it plays. Long bones, like the femur or humerus, act as levers, amplifying the pull of muscles to create motion. Flat bones, such as the skull or scapula, provide broad surfaces for protection and attachment. Short bones, found in the wrists and ankles, allow complex gliding movements. Irregular bones, like the vertebrae, combine elements of all these forms, adapting to their specific needs. Despite these differences, every bone shares the same internal architecture, a fusion of strength and lightness that speaks of both precision and grace. Surrounding each bone is a thin, fibrous membrane called the periosteum. It serves as the living skin of the skeleton, rich with nerves and blood vessels. The periosteum nourishes the bone beneath and provides an anchor for tendons and ligaments. When bone is injured, it is this outer layer that first responds, sending cells to begin the process of repair. The pain felt from a fracture or deep bruise often arises from the nerves within this membrane, alerting the body to protect and heal. Beneath this surface, new bone slowly forms, bridging the break until the structure is whole again. In time, the repair becomes indistinguishable from the original, a quiet testament to the body's resilience. Bone also plays a crucial role in maintaining the body's chemical balance. It acts as a vast reservoir for minerals, especially calcium and phosphorus, releasing them into the bloodstream when needed. These minerals are essential not only for bone health but also for nerve transmission, muscle contraction, and many other cellular functions. The endocrine system and the skeleton are thus deeply intertwined. When calcium levels drop, hormones signal the bones to release stored calcium. When levels rise, the bones absorb it again. This gentle exchange keeps the body in perfect equilibrium. The very shape of bone tells the story of movement and adaptation. The smooth surfaces where joints meet are covered with articular cartilage, a layer that cushions and allows frictionless motion. The roughened areas, where tendons attach, grow stronger with use, forming tiny ridges and protrusions called tubercles and crests. These landmarks are like the footprints of muscle on bone, recording the body's habits over time. In athletes or laborers, these features are often more pronounced, Even in the smallest bones, such as those of the hands or feet, each curve and groove serves a purpose, contributing to the delicate precision of human movement. When viewed as a whole, the nature of bone reveals the perfect balance between durability and renewal. It endures immense pressure, bears the weight of the entire body, and yet constantly rebuilds itself at the microscopic level. It protects the most fragile organs, the brain within the skull, the heart and lungs within the ribs, while also allowing the body the freedom to bend, stretch, and twist. Bone is, in every sense, both guardian and enabler. In moments of quiet reflection, one can almost sense this living structure beneath the skin. The bones warm from circulating blood, the joints resting softly in their sockets, the spine holding its steady curve. They have carried us from infancy through growth and change, adapting to every fall. And even now, as we pause and breathe, they continue their patient labor, renewing, strengthening, and sustaining. The nature of bone is not merely biological, it is poetic. It is the story of endurance woven into life itself, firm yet flexible, ancient yet forever new. Continuity, the physical memory of our every step, and as the body moves and rests, grows and heals, the bones beneath remind us that strength is not found in stillness alone, but in the living balance between permanence and change. 4. The meaning of a joint. Within the quiet framework of the skeleton lies a series of subtle meeting points, places where the rigid strength of bone yields to the soft possibility of movement. These meeting points are the joints, the articulations that connect one bone to another, allowing the body to move as a unified whole. They are the hinges of life, the delicate spaces that transform structure into motion. Without them, the human body would be little more than a still, unbending frame. With them, we walk, bend, twist, and reach. They are the silent mediators between strength and flexibility, stability and freedom. A joint, at its simplest, is a place of connection, yet within that simplicity lies extraordinary complexity. Balance two opposing forces, the need to move and the need to remain stable. It must permit flexibility while preventing the bones from slipping apart. It must allow fluid, graceful motion without sacrificing the firm support that keeps the body upright. The design of every joint is a response to these dual demands, shaped by millions of years of adaptation and refined by the subtle pressures of daily life. If one could look closely at a joint, one would see not just two bones meeting, but an entire community of tissues working together. At the heart of the joint lies cartilage, smooth, resilient, and slightly elastic. This thin layer covers the ends of the bones, acting like a cushion and reducing friction as they glide against one another. Without cartilage, movement would be harsh and painful, the bones grinding directly together. Surrounding the joint is a capsule, a soft envelope made of fibrous connective tissue. Within this capsule lies synovial fluid, a clear, viscous substance that lubricates the joint, nourishes the cartilage, and keeps everything moving silently and smoothly. Around the capsule, strong ligaments hold the bones in alignment, restricting excessive movement and guarding against injury. The entire structure is alive with purpose, every layer contributing to motion without compromise. The meaning of a joint goes far beyond anatomy. It is a place of balance between movement and stillness, between independence and connection. Each time a joint bends, a moment of cooperation unfolds. The bones rely on one another, sharing the burden of motion. The muscles pull, the tendons transmit the force, and the bones respond with a graceful precision that seems almost effortless. The smallest gestures, the turning of the head, the curling of a finger are born from this quiet dialogue between form and function. There are many types of joints in the human body, each designed for a particular purpose. Some joints are immovable, their task, to hold bones firmly together, such as the sutures in the skull. These fibrous joints are like the seams of a great architectural dome, ensuring strength where motion would be dangerous. Others, like those between the vertebrae or at the junction of the ribs and sternum, allow only limited movement, their slightly flexible cartilage providing just enough give to absorb shock and adjust to the body's motions. Then there are the synovial joints, the most mobile and complex of all, found in the shoulders, hips, elbows, knees, and many smaller places. They permit smooth, wide-ranging movement. Their design, both strong and supple, reflects the body's need to be both stable and free. When you lift your arm, multiple joints cooperate in the act. The shoulder joint, a ball and socket design, allows the humerus to rotate freely in nearly any direction. The elbow, a hinge joint, controls the simple bending and straightening of the arm. The wrist and fingers, with their smaller and more intricate joints, adjust and refine the motion. Together, they create a single, seamless gesture, something that feels simple, but in truth is a symphony of coordination. This cooperation extends throughout the body. Every movement we make involves the harmonious interplay of multiple joints working together in perfect balance. The human body depends on this balance more than we often realize. The ability to walk upright, for example, is a triumph of joint coordination. Each step involves a chain of motions, the hip flexing, the knee bending, the ankle shifting, the toes pushing off the ground. All of these movements occur in a rhythm so natural that we rarely think about it. Yet if one joint were to stiffen or fail, the entire chain would be disrupted. This is why the health of a single joint affects the posture and mobility of the whole body. The skeleton is not a collection of separate parts. It is a connected system, its joints acting as the soft hinges that bring stillness to life. The surfaces of bones within joints are marvels of engineering. The ends of the bones are shaped in complementary ways, one convex, one concave, so that they fit together perfectly. This design allows motion while keeping the bones aligned. Some joints, like the knee, include additional structures such as menisci, crescent-shaped discs of cartilage that deepen the joint and distribute pressure evenly. Others, like the shoulder, rely heavily on soft tissues for stability, since the shallow socket allows great freedom but less inherent strength. Each variation is a reflection of purpose. Some joints are built for stability, others for motion, and most for a delicate balance between the two. Though joints allow movement, they are also deeply protective. They absorb the shocks that travel through the skeleton each time we take a step or make a motion. The cartilage and synovial fluid act like a living suspension system, cushioning impact and reducing wear. Even the smallest joints, those between the tiny bones of the wrist or spine, play a role in this distribution of force, ensuring that no single bone bears too much strain. This is the quiet genius of the body's design, 1,000 small movements combining to preserve the whole. When a joint moves, it does not do so in isolation. Nerves surrounding the joint constantly send signals to the brain, providing information about position and motion, a sense known as proprioception. This subtle awareness allows us to move gracefully without needing to look at our limbs. It is what lets a pianist's fingers find the keys in darkness, or a walker adjust balance on uneven ground. The brain and the joints are in constant communication, a conversation of movement carried out in silence. The cartilage that cushions them can thin with age or overuse, and the synovial fluid can lose some of its smoothness. Surrounding muscles grow stronger to stabilize the joints, and movement itself becomes a form of nourishment. Gentle motion encourages the circulation of synovial fluid, delivering nutrients to the cartilage and maintaining its resilience. In this way, movement and health are intertwined. The more a joint moves within its natural range, the more alive it remains. There is a quiet beauty in recognizing that every joint is a meeting place, not just of bones, but of forces, materials, and purposes. They embody the cooperation of structure and motion, the interdependence of all parts of the body. When we stretch, walk, or simply breathe, we are engaging this entire system, awakening countless small articulations that work together to keep us fluid and balanced. If we could listen closely to the language of the body, we might hear the faint whisper of these joints in motion, the gentle sliding of surfaces, the stretch of ligaments, the fluid's subtle flow. It is not the sound of friction, but of harmony, of design functioning as it was meant to. Even in stillness, the joints hold us in quiet readiness, poised to move at the slightest impulse. They are the hinges of grace, the unseen artists of human motion. To understand the meaning of a joint is to see the skeleton not as a static frame, but as a living network of connections. Each articulation is a point of possibility, a place where stillness becomes motion and strength becomes flexibility. Together, they allow the body not only to move through the world, but to express itself within it through gestures, through rhythm, through the poetry of motion. The joints remind us that every act of life depends upon cooperation and that within the quiet architecture of our bodies lies a profound lesson in unity. 5. The elements that make a joint. Every movement the body performs, from the smallest turn of the head to the grandest stretch of the limbs, depends upon the silent collaboration of many parts within each joint. A joint is not merely a place where two bones meet. It is an intricate harmony of tissues, fluids, and fibers, all shaped for one purpose: to allow motion while preserving stability. To look upon a joint as a simple hinge or pivot would be to overlook its quiet complexity. Each one is an orchestra of living structures, each note played by a different element, blending strength, flexibility, and protection into a single act of motion. The foundation of every joint begins with the bones themselves. Where they meet, their surfaces are shaped with exquisite precision. Some are rounded like a ball, others flat, some concave, and others convex. These complementary shapes fit together perfectly, ensuring that motion is smooth and predictable. The ends of these bones are not bare or rigid. Instead, they are covered in a layer of articular cartilage, a smooth and resilient tissue that acts as both cushion and surface. To the touch, living cartilage would feel slick and slightly springy, glistening like polished stone softened by water. Its texture allows bones to glide effortlessly against one another without friction. This single element is what keeps the skeleton silent in motion. Without it, movement would grind and scrape, each step and gesture accompanied by pain. Cartilage is unique among the body's tissues. It is firm, yet flexible, capable of absorbing shock and distributing force evenly across a joint. It contains no blood vessels of its own. Instead, it is nourished by the surrounding synovial fluid, which seeps into its matrix to deliver oxygen and nutrients. Because of this, cartilage heals slowly when damaged, but it endures a lifetime of movement with remarkable persistence. Its structure is made of densely packed collagen fibers and specialized cells called chondrocytes, which maintain the tissue's smooth surface. Under pressure, cartilage compresses slightly, storing energy like a spring and releasing it as the joint moves. This subtle give and take transforms mechanical stress into graceful motion, turning the harshness of impact into something fluid and silent. Surrounding the joint is the capsule, a flexible envelope that holds everything in place. This capsule is made of tough connective tissue, woven tightly for strength yet elastic enough to accommodate movement. Its outer layer blends into the periosteum of the bones it connects, creating a continuous barrier that seals the joint cavity. Within this capsule lies the synovial membrane, a delicate inner lining that plays one of the most essential roles in joint function. The synovial membrane produces synovial fluid, a clear, viscous liquid that fills the joint space. It serves as a lubricant, reducing friction to nearly zero so that bone can glide over bone with ease. It also carries nourishment to the cartilage, keeping it supple and alive. Under a microscope, this fluid appears as a shimmering network of molecules, composed primarily of hyaluronic acid and lubricant substances that give it its characteristic smoothness. As the joint moves, the fluid circulates gently, spreading across the surfaces like a fine film of oil over glass. Each bend or rotation stirs it into motion, renewing its contact with every part of the cartilage. When the body rests, the fluid settles quietly back into place, pooling within the cavity like a calm sea waiting for the next tide of movement. The joint capsule does more than hold things together. It also communicates constantly with the rest of the body. Within its fibers are sensory receptors that detect, stretch, and tension, sending messages to the brain about position and movement. These signals form the basis of proprioception. Even without looking, you know the bend of your elbow or the angle of your ankle because your joints are speaking to your nervous system through countless tiny messages. This sensory harmony is what allows us to move gracefully and unconsciously, adjusting our balance and posture without deliberate thought. Encasing the joint further are ligaments, strong bands of fibrous tissue that connect one bone to another. They are the guardians of stability, preventing excessive movement that might strain or dislocate the joint. Ligaments vary in size and strength depending on their location and purpose. In the knee, for example, thick cruciate ligaments cross within the joint like the cords of a suspension bridge. In the shoulder, looser ligaments allow for a greater range of motion, trading some stability for flexibility. Despite their toughness, ligaments are living tissues, capable of adapting over time to changes in movement and strain. With gentle stretching, they lengthen slightly. With disuse, they may stiffen. Their quiet endurance ensures that motion always remains within safe and balanced limits. Alongside ligaments are tendons, the fibrous cords that connect muscle to bone. Though technically separate from the joint itself, they are inseparable in function. When a muscle contracts, the tendon transmits its force to the bone, pulling it into motion. The tendon slides smoothly within its sheath, guided by synovial fluid, much like that within the joint cavity. Around the wrist and ankle, where multiple tendons cross in tight spaces, small sacs called bursae cushion and protect them, reducing friction where tissue might otherwise rub against bone. These bursae, filled with the same synovial fluid, act as soft pillows of movement, ensuring that every gesture remains silent and effortless. Each of these elements, cartilage, capsule, membrane, fluid, ligaments, tendons, and bursae, works together to create an environment of perfect balance. The joint is not a static structure but a living ecosystem. Every time you move, pressure and motion stimulate the cells within these tissues, prompting them to renew themselves and maintain health. Motion itself becomes medicine. When the body remains active, synovial fluid circulates more freely, delivering nourishment where it is needed most. When we are still for too long, the flow slows, and the tissues begin to stiffen. It is a quiet reminder that movement is not merely function, it is life's expression through the body's design. When the bones meet properly, forces are distributed evenly across the surfaces, minimizing wear. If the balance is disturbed through injury, posture, or habit, the load shifts unevenly, and certain areas may bear too much strain. Over time, this imbalance can erode the smoothness of cartilage or overstretch the ligaments, yet the body remains adaptive, always seeking to restore harmony. Muscles strengthen or relax to correct posture. Fluid production may increase to protect a stressed joint. Imperfection. The system strives for equilibrium. When one contemplates these structures together, the joint emerges as a place of elegant cooperation. It is where strength meets grace, where the solidity of bone meets the softness of tissue. The materials that form it are unassuming collagen fibers, mineral salts, water, yet their arrangement achieves something extraordinary. It transforms rigidity into motion and pressure into poise. Each joint, no matter how small, embodies this design. The knuckles that flex with delicate precision, the hips that bear the body's weight, the spine that bends and turns, all follow the same principle of harmony between form and freedom. If you imagine the body at rest, lying still in quiet breath, your joints are not dormant. Even in stillness, they are alive with subtle motion, microscopic shifts in fluid, tiny pulses of circulation, faint stretches in the connective fibers. They prepare, always, for the next movement. The body's wisdom resides here, in these unseen spaces that hold together the architecture of life. The elements that make a joint are not merely mechanical parts. They are living participants in the continuous conversation between motion and stability. They remind us that flexibility does not mean fragility, and that true strength is not rigid but responsive. Within every joint lies a lesson in cooperation, a reminder that the beauty of movement comes not from any single part, but from the perfect balance of many working as one. And as we move through the world, bending, stretching, and reaching without thought, we carry within us these intricate and faithful companions, ensuring that every gesture remains a quiet celebration of life in motion. 6. How joints are classified. To understand how the body moves, it helps to see that not all joints are created for the same purpose. Some are meant to hold the skeleton firm, others to allow a gentle give, graceful motion. Each type is a reflection of the balance between movement and stability that the body must achieve to function. In their diversity, the joints tell a story of evolution and design of how the human body learned to stand upright, to walk, to grasp, and to express itself through motion. The classification of joints is not merely an academic division. It is a way of understanding how life has found harmony between strength and flexibility, permanence and adaptability. When scientists and anatomists describe joints, they often group them by structure and by function. The structural classification focuses on what the joint is made of, the material that binds one bone to another, and whether or not a space exists between them. The functional classification, on the other hand, describes how much movement a joint allows. Together, these perspectives reveal the range of motion that makes the human body both strong and graceful. There are 3 major structural types of joints: fibrous, cartilaginous, and synovial. Each represents a different way that bones connect to one another. Quart. The simplest, fibrous joints are those in which bones are bound tightly together by dense connective tissue. These joints allow little or no movement, serving instead to provide stability and protection. One need only think of the skull to imagine this type of connection. The bones of the skull are joined by fibrous sutures that fuse as we grow, holding the brain within a solid, protective vault. The seams between these bones are irregular, interlocking, and beautifully intricate, shaped almost like the jagged edges of puzzle pieces fitted perfectly together. Once fused, they are immovable. Some, like the joints between the tibia and fibula of the lower leg, allow a slight give, a small but useful flexibility that absorbs impact and helps the body adapt to uneven surfaces. These are known as syndesmosis joints that rely on bands or sheets of fibrous tissue to hold bones together. Though they move very little, their small degree of motion is essential to the fluid mechanics of the skeleton. The gentle elasticity of these fibers ensures that bones can withstand tension without breaking apart, a subtle example of how strength and flexibility coexist, even in stillness. The next category, cartilaginous joints, represents a middle ground between immovable and freely movable. In these joints, bones are connected by cartilage rather than dense fibrous tissue. This arrangement allows limited motion while maintaining stability. Cartilaginous joints appear in places where the body needs both firmness and a small measure of flexibility in the spine. For example, where the vertebrae are joined by discs of cartilage. These intervertebral discs act as cushions, absorbing the shock of each step, each bend, and each twist. They compress slightly under pressure, then expand again, maintaining the gentle rhythm of movement that characterizes the human body. Another example of a cartilaginous joint can be found where the ribs meet the sternum. The cartilage here allows the chest to expand and contract with each breath. It is a subtle motion, but without it, the act of breathing would be impossible. In this way, cartilaginous joints embody the principle of quiet motion movement that is not dramatic or visible, but constant and vital. The materials that form these joints are themselves living tissues, nourished by the flow of fluids and by the gentle movement they enable. They remind us that even limited motion plays a crucial role in maintaining life. Finally, we come to the most familiar and complex type of joint, the synovial joint. These are the joints of movement, the places where the body achieves its greatest range and freedom. They are characterized by a distinct cavity filled with synovial fluid, a marvel of biological engineering that allows bones to move with almost frictionless grace. Around this cavity is a joint capsule, strong yet flexible, and within it, the bones are lined with articular cartilage that glides effortlessly across its opposing surface. Synovial joints are what make the human form expressive. They allow us to reach, to dance, to turn our gaze, to walk and run and embrace. There are many variations within this single category, each tailored for a particular kind of movement. The ball and socket joint, found in the shoulder and hip, permits rotation in almost every direction. The hinge joint, like that of the elbow and knee, allows bending and straightening in a single plane, much like the motion of a door. Pivot joints, such as those in the neck, enable rotation, letting us turn our heads or rotate our forearms. Condyloid and saddle joints offer more nuanced movements, subtle ovals and tilts, as seen in the wrist and thumb. Gliding joints, the smallest of all, allow bones to slide past one another in quiet cooperation, as in the joints of the spine and the tiny bones of the wrist. Each type represents a different balance of mobility and stability. The shoulder, for example, sacrifices a measure of security for the sake of freedom. Its shallow socket, allowing wide arcs of motion at the cost of being more vulnerable to dislocation. The hip, in contrast, is deeply set within its socket, trading some range for greater strength and endurance. Both are ball and socket joints, yet they embody opposite priorities. The variety of these designs shows how the body finds different solutions to the same challenge: how to move without losing strength. When viewed functionally, joints are classified into three main groups according to their degree of movement: synarthroses, which are immovable; amphiarthroses, which allow limited motion; and diarthroses, which are freely movable. Synarthroses include the fibrous joints of the skull, steadfast and protective. Amphiarthroses include the cartilaginous joints of the spine, quietly flexible and supportive. Diarthroses are the synovial joints, the instruments of free movement that define human activity. These three categories, stillness, slight motion, and full motion, can be thought of as the body's vocabulary of movement. Each word, each gesture, draws from them in varying degrees. The transitions between these categories are gradual, not abrupt. Nature rarely works in sharp boundaries. Instead, it blends one form into another, adjusting for the specific demands of each region of the body. The human spine is a perfect example of this gradient. The vertebrae near the skull are relatively mobile, allowing the head to turn and tilt, while those near the lower back are larger and more stable, supporting the weight of the torso. The same principle applies to the ribs, which are partly fixed and partly flexible, their cartilage acting as a hinge for breathing. Everywhere in the body, form and function merge in smooth continuity. The classification of joints, then, is not just a matter of naming or categorizing. It is a reflection of life's quiet engineering. It reveals how the human body negotiates between the need for movement and the necessity of endurance. Each type of joint represents a compromise, a balance suited to its role. The skull's immovable sutures ensure safety for the mind. The spine's flexible discs give motion to the trunk. The limb's synovial joints bring agility and grace. The human form is built upon this architecture of contrasts, each joint a solution to the question of how to move without breaking, how to be strong without being rigid. When we walk, stretch, or even sit in stillness, these different types of joints work together, each performing its function in quiet synchrony. They create a chain of motion that runs from head to toe, a continuous interplay between the stable and the mobile. Without the stillness of fibrous joints, there would be no firm foundation. Without the flexibility of cartilaginous joints, no fluidity. Without the freedom of synovial joints, no expression, no dance, no life in motion. To classify the joints of the body is to glimpse the order behind its movements, an order that is at once mechanical and poetic. It is the body's way of showing that motion is not chaos, but harmony. The silent geometry of each joint, from the fused sutures of the skull to the delicate pivots of the neck. It is in this intricate hierarchy that we find the true wonder of the skeleton, not just in its strength, but in the thoughtful variation that allows us to live within both stillness and motion. 7 fibrous joints, the bonds of stillness. Throughout the living skeleton, there are places where movement is not the goal, where the body's design favors endurance over motion, protection over flexibility. These are the fibrous joints, the bonds of stillness that hold the architecture of the skeleton firmly together. They are the quiet guardians of the body's form, anchoring bone to bone with strength and precision. While other joints allow rotation and bending, fibrous joints are built for permanence. They exist to keep the structure whole, to protect the delicate contents within, and to preserve the steady shape of the human frame through a lifetime of change. At first glance, one might think of stillness as something lifeless, a lack of motion or energy. But in the human body, stillness is deeply alive. It is the foundation that allows movement elsewhere to exist. Just as a tree can only sway gracefully because its roots hold firm, so too can the body move freely only because some of its joints remain immovable. Fibrous joints embody this principle. They form where stability is vital in the vault of the skull, between the small bones of the face, and in the sturdy connections that bind the lower leg. Their quiet work ensures that the moving parts of the skeleton have something strong to rely on. The most familiar of these joints are the sutures of the skull. They are among the most intricate and delicate connections in the human body. When a child is born, the skull is not a single solid bone, but a collection of plates joined by flexible tissue. These spaces, known as fontanelles, allow the skull to compress slightly during birth and to expand as the brain grows in early life. As time passes, these soft membranes gradually harden, and the plates begin to knit together through fibrous connective tissue. This process continues for many years, until the sutures fuse almost completely in adulthood. Yet even then, the lines of their union remain visible, like faint rivers flowing across a map of bone. Each curve and interlocking edge adds strength, distributing forces evenly and ensuring that the skull can protect its precious contents without yielding. The sutures of the skull are remarkable in their design. They are not smooth seams, but beautifully jagged, their edges shaped like the teeth of a zipper. This interlocking pattern provides both strength and resistance to separation, though they allow no motion in daily life. They have a subtle elasticity that absorbs the small vibrations and shocks that pass through the head. Beneath the surface, the fibrous tissue that binds them is rich with tiny blood vessels and specialized cells that maintain the joint's integrity. Even in their stillness, these joints are living, adaptive, and sensitive to the needs of the body they protect. Fibrous joints are not confined to the skull. They appear wherever the body requires unyielding support. Between the teeth and the jawbone lies a type of fibrous joint called a gomphosis. Here, each tooth is anchored within its socket by a network of fine fibers known as the periodontal ligament. These fibers hold the tooth securely in place, yet with just enough flexibility to absorb the forces of chewing and speaking. It is a connection both firm and forgiving, one that allows the tooth to withstand enormous pressure without breaking. Like all fibrous joints, it relies on strength and tension rather than movement and freedom. Another example lies in the lower leg, where the tibia and fibula run parallel to one another. These bones are connected by a syndesmosis, a fibrous membrane that stretches between them like a strong sheet. This joint does not permit true motion, but it provides stability and resistance, ensuring that the two bones move as one while bearing the body's weight. The same type of connection can be found in the forearm between the radius and ulna, helping to maintain alignment and distribute forces during rotation. Though these joints are not visible from the outside, their quiet resilience supports every step, every grasp, and every act of balance. The connective tissue that defines fibrous joints is primarily composed of collagen, one of the body's most abundant and versatile proteins. Collagen fibers are arranged in tight bundles, woven together like threads in a rope. This gives fibrous joints their incredible tensile strength, the ability to resist being pulled apart. These fibers are not lifeless cords but living tissue, constantly renewed by the cells that inhabit them. They respond subtly to the stresses of life, strengthening under repeated tension and weakening if neglected. In this way, even the still joints of the body participate in its ongoing rhythm of adaptation. Though fibrous joints are largely immobile, they play a critical role in the body's flexibility of function. They form the stable anchor points from which motion originates. The head can turn and tilt smoothly on the neck only because the skull itself is solid. The arms and legs can move freely because their long bones are supported by unyielding connections that prevent collapse. In standing, walking, or lifting, the fibrous joints act as the pillars of the body's internal architecture, distributing force and preserving alignment. Without them, the movements we take for granted would be impossible or dangerous. It is easy to forget that these seemingly rigid joints also evolve through time. In early life, many fibrous joints are not yet fully formed. They exist as softer tissues that gradually mature. In older age, the opposite may occur. The connective tissue can harden further, and small movements that once existed may disappear entirely. Even so, this progression is part of the body's natural adaptation, adjusting its balance between flexibility and protection according to need. The skull that begins in softness ends in enduring stillness, a transformation that mirrors the cycle of growth and preservation that defines all living structures. The stillness of fibrous joints carries a quiet symbolism as well. They remind us that not all strength is visible, and not all movement is necessary. Sometimes, what allows life to flourish is the capacity to remain steady. The sutures of the skull protect the brain, not by moving, but by holding firm. The ligaments of the jaw steady the teeth through unyielding grip. The membranes of the leg keep the bones aligned through quiet endurance. In their silence, these joints teach the body stability, the art of remaining grounded even as everything around it moves. When viewed closely, the fibrous joints also demonstrate how beautifully the body integrates the immovable with the mobile. They exist beside joints of great freedom, complementing them like pauses in a melody. The stillness of the skull enhances the movement of the neck. The steadiness of the lower leg supports the flexion of the knee and ankle. It is this interplay between fixed and fluid that creates the body's overall balance. Without stillness, motion would be chaotic. Without motion, stillness would become stagnation. Together, they create the gentle equilibrium of human movement. To imagine the fibrous joints at work is to picture the foundation of a great structure. They are the stones at the base of an arch, the silent parts that never shift, allowing all else to remain upright. They do not attract attention, for their work is done in the background, unnoticed, yet essential. They do not seek movement or glory, they simply endure, serving their purpose with quiet perfection. In the end, fibrous joints reveal something profound about the nature of the skeleton, that stability is not the absence of life, but one of its deepest expressions. The immovable sutures of the skull, the unyielding ligaments of the leg, the steadfast fibers that hold the teeth, all speak of a body designed not just to move, but to last. They remind us that beneath the graceful arcs and flowing motions of the human form lies a foundation of stillness, a strength that never wavers. Stillness. Life finds its balance, its protection, and its quiet continuity. 8 cartilaginous joints, cushioned connections. Within the architecture of the skeleton, there exists a gentler kind of connection, one that stands between stillness and freedom, between firmness and motion. These are the cartilaginous joints, the quiet bridges of the body, where bones meet not in rigid fusion but in flexible union. They are the joints of gentle compromise, designed to allow limited movement while maintaining stability. Where fibrous joints hold fast and synovial joints glide freely, cartilaginous joints do something in between. They bend just enough to soften impact, to absorb pressure, to keep the body resilient. To understand their purpose, one must imagine the balance of forces that runs through the skeleton. Each step, each breath, each subtle twist of the spine sends vibrations and weight down through the body. If every joint were fixed, those forces would strike the bones like hammer blows. If every joint were loose and mobile, the structure would collapse under its own instability. The cartilaginous joints resolve this tension with quiet grace. They permit a small but essential motion, a tiny give that protects both the joints above and the bones they connect. They are the buffers of life, the living shock absorbers that turn pressure into poise. There are 2 principal forms of cartilaginous joints, synchondroses and symphyses. Though their names sound technical, their essence is simple. In synchondroses, bones are joined entirely by hyaline cartilage, a smooth, glass-like material that provides firm but flexible union. These joints are found where growth or transition occurs, for example, between the bones of a developing child. At the ends of long bones, before maturity, plates of cartilage allow the skeleton to lengthen as the body grows. Over time, these plates gradually ossify, becoming bone themselves. The joint then disappears, leaving behind a trace of its earlier work. In this way, the synchondrosis is both a connection and a stage of transformation, a temporary bridge between youth and adulthood, flexibility and strength. In adults, synchondroses can still be found in a few select places, such as where the first rib meets the sternum. This joint must allow a small movement as the chest expands and contracts with breathing, yet it remains strong enough to support the rib cage's protective function. The cartilage here acts like a hinge that moves so subtly we do not notice it, though it flexes with every breath we take. In its simplicity, it performs one of the body's most continuous labors, the rhythm of respiration, unbroken from birth to death. The second type, symphyses, are more enduring. In these joints, bones are united by fibrocartilage, a tougher, more fibrous material than the smooth hyaline type. Fibrocartilage combines strength with elasticity, resisting compression while allowing limited movement. The best-known examples of symphyses lie deep within the body, between the vertebrae of the spine and at the pubic symphysis, where the 2 halves of the pelvis meet in front. These joints are designed not for dramatic motion but for constant, subtle adjustments that maintain balance and absorb stress. They are the quiet, steady workers of the skeletal system, always active yet rarely noticed. Consider the spine, that central pillar of human posture. It is not a single rigid column but a chain of 24 vertebrae, each separated by an intervertebral disc of fibrocartilage. These discs are the essence of the cartilaginous joint's function. Each one consists of a tough outer ring of fibers surrounding a soft, gel-like core. When the body moves, bending, twisting, lifting, the discs compress slightly, distributing pressure evenly and protecting the vertebrae from damage. Over the course of a single day, the discs may compress enough to reduce a person's height by a few millimeters, then re-expand during rest. In this subtle rhythm, we can see the living adaptability of cartilaginous joints, firm when needed, flexible when called upon, restoring themselves through cycles of pressure and release. The pubic symphysis serves a different but equally elegant role. It unites the two halves of the pelvis, forming a joint that is both strong and forgiving. Under ordinary circumstances, it allows only the smallest movement, keeping the pelvis steady during walking or standing. Yet during childbirth, hormones soften the fibrocartilage, increasing flexibility so the pelvic bones can widen slightly to allow passage of the newborn. Afterward, the joint returns to its previous firmness. This temporary transformation is a remarkable example of how living tissue can adapt to serve life's most essential purposes. The pubic symphysis, though small and hidden from view, carries within it the quiet strength of generations, a living link between the structural and the nurturing, the mechanical and the maternal. Its surface is smooth and glassy, yet beneath that lies a matrix of fibers arranged in intricate layers. These fibers give it resilience, the ability to bend and return to shape without losing integrity. Within this matrix are specialized cells called chondrocytes, which maintain the tissue by producing the proteins and fluids it needs. Unlike bone, cartilage contains no blood vessels. It is nourished instead by diffusion from surrounding tissues and by the gentle motion that pushes fluid in and out of its surface. This means that movement, even the smallest motion, is essential for its health. When it moves, the tissue stays alive, hydrated, and strong. Thus, even the limited motion of cartilaginous joints is vital. It keeps the tissue young through the quiet rhythm of use. The balance between firmness and motion that defines cartilaginous joints also reflects a larger truth about the human body, that strength alone is not enough, and flexibility alone cannot sustain. The spine's intervertebral discs must be strong enough to carry the weight of the upper body, yet soft enough to cushion every step. The ribs must protect the heart and lungs. The pelvis must hold the body's weight when standing, yet yield when life itself begins anew. Each of these functions is made possible by the gentle resilience of cartilage, a tissue that endures through compromise, adapting constantly to the demands placed upon it. If one could see the cartilaginous joints in motion, the effect would be subtle. A quiet bending, a minute compression, a small but vital shift. Unlike the visible rotations of the shoulder or the bending of the knee, these movements are hidden deep within, felt rather than seen. They are the body's internal rhythm, the unseen choreography that allows it to move smoothly without strain. In stillness, they maintain posture. In motion, they distribute forces. In rest, they recover and renew. Even in sleep, the cartilage continues its slow work of repair, drawing in fluid and nutrients as the pressure of the day fades away. In their quiet way, cartilaginous joints embody endurance through softness. They do not resist pressure by opposing it, but by yielding to it, absorbing and redistributing it until balance is restored. It is a principle that nature repeats often in the sway of trees that bend with the wind rather than break. In the way water shapes stone, not by force, but by persistence, the cartilaginous joints are the body's expression of that same wisdom. Through them, we learn that flexibility and strength are not opposites, but partners in survival. To contemplate these joints is to glimpse the poetry of the body's design. Every vertebra, every rib, every subtle connection in the spine and chest moves just enough to sustain comfort, protect organs, and maintain alignment. The movements are too small to notice, yet without them, life would become rigid and fragile. The cartilaginous joints remind us that life endures not through resistance, but through graceful adaptation. In their quiet resilience, they teach the body, and perhaps the mind, that balance is found not in unyielding stillness, but in gentle, continuous adjustment. 9 synovial joints. The miracle of motion. Among all the connections within the human body, none are as fluid, as versatile, or as full of quiet wonder as the synovial joints. They are the true architects of motion, the places where the still strength of bone meets the graceful freedom of movement. Every rotation of the shoulder, every bend of the knee, every tilt of the wrist and sway of the spine is made possible by these extraordinary structures. They are small worlds of motion, contained yet boundless, each designed with such precision that even the simplest gesture becomes a marvel of natural engineering. When one pauses to think that every breath, every step, and every act of expression relies on their delicate balance, it becomes clear why these joints are often called the miracle of motion. A synovial joint begins with the same foundation as all others, 2 bones meeting at their ends. Yet what distinguishes it from the fibrous and cartilaginous varieties is the presence of a small but vital space, the joint cavity. This cavity, filled with a clear, viscous substance called synovial fluid, transforms the meeting of bones into something fluid and frictionless. It is the difference between rigidity and grace. Within this protected pocket, the bones do not grind or press directly against one another. Instead, they glide, cushioned by cartilage and bathed in the nourishing fluid that reduces resistance almost to nothing. The motion that results feels effortless, silent, and smooth, the quiet perfection of nature's design. The bones that form a synovial joint are capped with articular cartilage, a thin layer of smooth, glassy tissue that both protects and cushions. Though only a few millimeters thick, this layer performs miracles. It distributes weight evenly across the joint, prevents wear, and allows surfaces to move past one another without friction. If one could look closely at this cartilage under magnification, one would see a network of collagen fibers arranged in flowing layers, each oriented to resist different kinds of stress. Within this matrix lie the chondrocytes, the living cells that maintain the tissue, producing the materials that keep it resilient and smooth. The result is a surface that can endure decades of motion, supporting millions of steps and gestures with almost no sound or strain. Capsule, a double-layered enclosure that holds the joint together while allowing flexibility. The outer layer, known as the fibrous capsule, is strong and protective, preventing dislocation and shielding the delicate interior from external stress. The inner layer, the synovial membrane, is softer and alive with activity. It is here that the synovial fluid is produced, a transparent, slippery liquid that nourishes the cartilage and lubricates every movement. This fluid is the joint's lifeblood, constantly renewed and circulated through motion itself. When we move, the pressure changes within the joint help distribute the fluid across the surfaces, ensuring that every part remains bathed and protected. Even the simplest gesture, a slow stretch of the fingers, or a gentle rotation of the neck, stirs this fluid into motion, keeping the joint alive and supple. The brilliance of the synovial joint lies not only in its materials but in its structure. Each type of synovial joint is shaped for a specific purpose, a perfect balance between range of motion and stability. The shoulder and hip, for instance, are ball and socket joints, where a rounded bone fits into a cup-shaped cavity. This design allows motion in almost every direction, forward, backward, sideways, and around in smooth circles. The freedom it provides gives the arms and legs their expressive reach, but such freedom requires careful control. Muscles, tendons, and ligaments surround the joint, holding it steady while permitting its vast motion. Without this support, the same flexibility that allows beauty and grace would become instability and vulnerability. In every ball and socket joint, The body's design speaks of freedom guided by restraint. Other synovial joints favor precision over range. The hinge joints of the elbows and knees move in a single plane, opening and closing like the quiet swing of a door. Their stability comes from their simplicity, motion limited to one direction but executed with strength and control. The pivot joints, such as the one at the base of the skull and between the bones of the forearm, allow rotation, a turning that makes it possible to nod no, to rotate the wrist, or to turn the head toward a sound. The condyloid and saddle joints, found in the wrist and thumb, provide subtle, multi-directional glides and tilts that give the hand its remarkable dexterity. Then there are the gliding joints, small, flat surfaces in the wrists, ankles, and spine, where bones slide past each other in quiet coordination. Together, these types form the complete vocabulary of human movement, each one contributing to the rhythm and grace of life in motion. The ligaments that surround synovial joints act as guardians, ensuring that freedom does not become excess. They are strong bands of connective tissue that bind bone to bone, limiting motion to safe boundaries. In the knee, thick cruciate ligaments cross deep within the joint, forming an X-shaped support that maintains alignment even under heavy load. In the shoulder, looser ligaments permit wide movement but rely on surrounding muscles for extra stability. This interplay of tissue, ligament, and muscle, bone, and fluid forms a system of balance so intricate that we perform thousands of movements daily without conscious thought. Every reach, every turn, every lift is executed with perfect cooperation between the rigid and the soft, the strong and the yielding. What makes synovial joints especially extraordinary is that they remain quiet even under immense demand. A healthy joint moves without a sound, its surfaces gliding past one another with the ease of silk sliding over glass. The cartilage, the fluid, and the capsule together create a system that minimizes friction to near zero. It is only when something goes wrong, when the cartilage thins, when the fluid loses its smoothness, when inflammation disturbs the membrane, that sound and pain intrude upon the silence. In their natural state, synovial joints are almost invisible to our awareness. Their perfection is their anonymity. They do their work so well that we never feel them at all. Within these joints also lies an astonishing sensitivity. Tiny receptors embedded in the capsule and ligaments constantly monitor tension, position, and movement. They send continuous messages to the brain, updating it about the body's orientation in space. This is how we can close our eyes and still know where our hands are, how we can walk or dance without consciously tracking every step. The nervous system and the synovial joints work together in a silent partnership, translating mechanical movement into sensory awareness. It is a union of structure and perception, the physical and the mental intertwined. As with all living structures, synovial joints evolve through life. In youth, the cartilage is thick and pliant, the fluid plentiful, the ligaments flexible. With age, the materials change. The fluid may thicken slightly. The cartilage may lose some of its sheen. The capsule may tighten. Yet movement itself remains the great sustainer. Gentle, regular motion stimulates the synovial membrane, encouraging the renewal of fluid and maintaining the elasticity of tissue. The very act of using the joints nourishes them. Stillness, by contrast, leads to stiffness. The fluid grows sluggish, and the tissues become less supple. This is one of the paradoxes of the human body, that motion preserves motion. The miracle of the synovial joint depends not only on its design, but on the life that flows through it. There is a quiet poetry in the way these joints embody balance. They combine opposites with such precision that it is difficult to separate one quality from another. They are strong but flexible, stable but free, silent yet full of activity. Within each, the body achieves what seems impossible. Bones, the hardest of materials, moving against one another without harm. It is this harmony that allows a child to run, a hand to create, a dancer to glide, and even a breath to expand and release. The synovial joints transform the static beauty of the skeleton into living grace. To contemplate them is to appreciate the intelligence of design that permeates the body. Each joint, from the largest hip to the smallest finger, carries within it a perfect conversation between motion and rest. They are the places where stillness becomes movement and where structure becomes expression. Every day, without awareness, they perform their quiet miracle bending, rotating, gliding, holding, and returning to rest. They are not only mechanical wonders but also symbols of life's gentlest truth, that strength and freedom are not opposites, but partners in harmony. Through their endless motion, the synovial joints whisper the language of living, a language written in the soft glide of bone on bone, in the fluid that nourishes, and in the unspoken balance that makes motion itself an act of grace. 10. Ball and socket joints, circles of freedom. Among all the joints that make up the body's living machinery, few inspire such quiet awe as the ball and socket joints. They are the wide gates of motion, the graceful centers around which so many of our gestures unfold. In these joints, the human form finds its fullest freedom, an ability to sweep, to rotate, to turn in endless, flowing circles. They exist in only two main places within the body, at the shoulder and the hip, yet through their design, the body gains the ability to reach outward and to move forward, to create, to walk, and to dance. These two joints, similar in principle but distinct in personality, represent the essence of fluid movement bound within the limits of strength. A ball and socket joint is built upon a simple but perfect geometry. At one end of the connection lies a rounded head of bone, the ball, smooth and polished, shaped like a sphere. At the other lies a concave depression, the socket ready to receive it. When the ball fits into the socket, the two together create a point of connection capable of rotation in nearly every direction. This is what anatomists call a multiaxial joint, meaning it can move along several planes at once, forward and backward, side to side, and in graceful rotations. It is this form that allows the arm to swing in a wide arc, the leg to turn outward and inward, and the entire body to adapt its posture with quiet fluidity. In the shoulder, this joint is known as the glenohumeral joint, where the rounded head of the humerus fits into the shallow cavity of the scapula, called the glenoid fossa. The design here favors motion above all else. The socket is relatively shallow, allowing the arm to move freely in almost any direction. Because of this openness, the shoulder becomes the most mobile joint in the body, capable of reaching overhead, across the body, or behind it with ease. Yet such freedom requires delicate control. The shoulder relies not on the depth of its socket, but on a surrounding network of muscles and tendons, the rotator cuff, to keep the head of the humerus secure. These muscles form a living harness, guiding the joint through its wide range of motion while maintaining its stability. Their continuous, unseen labor is what makes each graceful reach possible. The hip, by contrast, takes the same design and turns it towards strength and endurance. Here, the rounded head of the femur fits into a deep, cup-like socket in the pelvis called the acetabulum. The fit is snug and secure, designed to bear the body's weight and transmit powerful forces through each step and stride. The ligaments that surround the hip are among the strongest in the body, wrapping the joint like thick cords that prevent dislocation even under immense pressure. The trade-off for this stability is a slightly reduced range of motion compared with the shoulder, but it is a balance perfectly suited to the joint's purpose. The hip does not need to reach overhead or behind the back. Its role is to provide the steady axis of walking and standing, the anchor of human motion. In both joints, articular cartilage covers the surfaces where bone meets bone. Beneath the capsule, synovial fluid flows in response to movement, cushioning the forces that pass through the joint. As the limbs move, this fluid circulates quietly, nourishing the cartilage and carrying away the microscopic wear of daily motion. Each step, each stretch, keeps the joint alive, for motion is what sustains it. Without use, the fluid thickens, and the tissues grow still, reminding us that the body was made for movement and not for endless rest. The ball and socket joints serve as the meeting places of strength and grace. The shoulder, light and expressive, gives the arm its reach and the hand its full vocabulary of motion. Every stroke of a brush, every embrace, every small wave of greeting begins here, where the spherical head of bone rolls within its smooth hollow. The hip, powerful and grounded, gives the body its stride, supporting its weight and giving stability to the spine. Through it we find our ability to walk upright, to balance, and to move through space with quiet dignity. One joint allows expression, the other, endurance. Together, they define much of what makes human motion both purposeful and beautiful. To understand how these joints move, one can imagine the smooth glide of a sphere within a bowl of liquid. The motion is continuous, without edges or stops, flowing in arcs and circles. The shoulder can lift, rotate, and roll with remarkable fluidity, allowing the hand to trace shapes in the air. The hip, though more restrained, moves in steady pendulums, carrying the body forward in rhythmic steps. The geometry is the same, but the feeling differs, one airy and expressive, the other solid and feeler, rhythmic. Each complements the other, and together they complete the body's balance of freedom and stability. The muscles that cross these joints form intricate systems of control. Around the shoulder, the deltoid, pectoral, and rotator cuff muscles work in coordination, each fiber contributing to a symphony of motion. When one lifts the arm, dozens of small adjustments occur to keep the ball centered within its socket. At the hip, large muscles such as the gluteals and iliopsoas power the leg's motion, while smaller, stabilizing muscles fine-tune its position. These muscular companions are what transform mechanical possibility into graceful reality. Without them, the joints would be unstable or awkward. With them, motion becomes effortless. Even in rest, the ball and socket joints are never truly still. They carry the body's weight and respond to every small shift of balance. When you stand quietly, the head of the femur adjusts within its socket, maintaining perfect alignment. When you breathe, the subtle movement of the ribcage shifts the position of the shoulders, and the humeral heads respond with minute rotations. This living responsiveness is what keeps the joints supple. They are not hinges fixed in place, but living connections constantly sensing, adjusting. Their beauty lies in this combination of stillness and readiness, always at rest, yet always prepared to move. Because of their freedom, these joints are also more vulnerable than most. The same openness that grants the shoulder its vast range makes it susceptible to strain if the supporting muscles weaken or tire. The hip, though stronger, can suffer wear when its cartilage thins or its balance shifts. Yet even in this vulnerability lies a lesson about the body's wisdom. Every gift of freedom carries the responsibility of care. The joints respond best to balance neither forced stillness nor overuse, but steady and natural motion that keeps the tissues nourished and alive. To contemplate the ball and socket joints is to witness the body's mastery of form and function. They are the perfect circles within the geometry of the skeleton, uniting roundness with motion. They allow the arm to describe the arc of the horizon, the leg to push the ground away, and the entire body to move as a fluid whole. They remind us that motion is not chaos but harmony, a sequence of precise, circular paths guided by structure and sustained by life. In the quiet of reflection, one might imagine the subtle rotations that continue even in stillness, the small adjustments of the hips as you breathe, the faint settling of the shoulders as you exhale. Within those movements lies the whisper of the body's intelligence, the gentle conversation between bone, muscle, and motion. The ball and socket joints are the heart of that conversation, where strength meets fluidity, where architecture becomes art. Through them, the skeleton comes to life, and the human body finds its most graceful expression, circles of freedom traced endlessly in the silence of living motion. 11 hinge joints. The simple elegance of bending. In the grand design of the human body, where some joints turn and rotate in graceful arcs, others move in quiet, deliberate simplicity. These are the hinge joints, the fundamental instruments of bending and straightening, the silent hinges upon which much of our motion depends. They are unassuming in their form, yet powerful in their function, translating the body's energy into direct, purposeful movement. While the ball and socket joints speak of freedom and rotation, the hinge joints embody focus and control. Through them, the body learns precision, the rhythmic opening and closing of limbs, the subtle balance between power and restraint. A hinge joint, as its name suggests, operates much like the hinge of a door. It allows motion along a single plane, usually permitting flexion and extension, the gentle arc of closing and opening. This limited range may seem simple compared to the vast rotations of the shoulder or hip, but within that simplicity lies efficiency and strength. The hinge joint's design ensures stability, directing forces in one direction and minimizing strain in others. It is the joint of work and motion, allowing the arms to lift, the legs to walk. Each time we move, we rely upon their quiet rhythm without ever thinking of the complexity hidden within their apparent simplicity. The classic examples of hinge joints are found in the elbow, knee, fingers, and toes. Each carries the same basic principle, though adapted for its particular role. At the elbow, the humerus of the upper arm meets the ulna of the forearm in a smooth groove and notch arrangement, forming a hinge that allows the arm to bend and straighten with precision. The radius, the other bone of the forearm, adds a subtle rotation, but the main bending action belongs to the humeral nard joint. Around it, a tight capsule and strong ligaments ensure stability, preventing sideways movement that might damage the structure. The elbow's design is one of focused purpose. It provides the strength to lift and the control to lower, turning muscular contraction into graceful efficiency. The knee, larger and more complex, carries the same hinge principle but on a grander scale. Here, the femur and tibia meet in a broad, curved interface, cushioned by layers of cartilage and two crescent-shaped pads known as menisci. These menisci act as buffers, distributing weight evenly and absorbing the shock of each step. The knee's hinge allows the leg to flex and extend, transforming the body's weight into forward motion. Around it, a lattice of ligaments provides support, the anterior and posterior cruciate ligaments crossing deep within, the collateral ligaments flanking the sides, all working together to hold the joint steady while it bends. Despite its apparent simplicity, the knee's design is one of exquisite balance. It must bear the full weight of the body, absorb impact, and yet allow enough motion for walking, running, kneeling, and rising. It achieves all this through the quiet precision of its hinge mechanism. In the hands and feet, hinge joints appear on a smaller scale but with no less importance. Each finger and toe bends at multiple points, the interphalangeal joints where tiny hinges open and close to create delicate control. The hand, in particular, depends on these joints for its expressive range. When one curls the fingers to grasp an object, the hinge joints of the knuckles and digits work in perfect sequence, their small arcs combining into smooth, coordinated motion. They are the joints of craftsmanship, enabling fine motor control, the act of writing, the creation of art, or the simple comfort of touch. In the feet, the same principle allows stability in walking, each toe flexing slightly to adjust balance and maintain rhythm. What makes hinge joints remarkable is the way they achieve strength through limitation. By restricting motion to a single direction, They prevent the unpredictable twisting and sliding that could lead to injury. Their very constraint is what gives them power. Like the hinge of a gate that holds firm despite constant use, these joints withstand enormous forces by guiding them along safe, predictable paths. The muscles that operate them are therefore able to act with focus. In the arm, the biceps and triceps form an elegant partnership, one contracting to flex the elbow, the other extending it again. Their opposing actions create harmony, each movement balanced by its counter movement. This mirrored rhythm is a theme repeated throughout the body's design, a gentle ebb and flow that keeps motion smooth and controlled. The structure of a hinge joint reflects its purpose. The surfaces of the bones are shaped to match, perfectly one rounded, one concave, ensuring a snug fit that directs movement without friction. Articular cartilage covers these surfaces, reducing resistance and absorbing shock. Synovial fluid fills the joint cavity, providing lubrication and nourishment. The capsule surrounding the joint is reinforced by ligaments that prevent sideways slip while allowing full bending. In every detail, the hinge joint's architecture speaks of efficiency and trustworthiness. It is built to move often, to endure strain, and to do so quietly, without complaint. Though hinge joints appear simple, their movements are part of a greater choreography that runs through the entire body. When one walks, for example, the hinge of the knee does not act alone. As the leg bends, the hip rotates slightly, the ankle adjusts, and the spine shifts balance to maintain alignment. Each joint responds to the others, their combined motion forming the fluid rhythm of a single step. The same is true for the elbow, which works in concert with the shoulder and wrist to produce smooth, accurate movement. This interconnectedness means that the hinge joint, though individually straightforward, is never truly isolated. It belongs to a system of harmony, where every action resonates through the body's network of motion. Even in stillness, hinge joints are alive with subtle activity. The synovial fluid within them circulates gently as we breathe, responding to small changes in pressure and posture. The cartilage rests, yet continues its quiet exchange of nutrients. Ligaments maintain their soft tension, ready for the next movement. The body never truly stops. Even in repose, it prepares for motion. The hinge joints hold the memory of movement within their form, the rhythm of walking, the bend of reaching, the gesture of touch, all contained in their simple architecture. There is also an elegance in the way these joints connect strength to grace. They allow motion that is both powerful and measured. When one kneels, the hinge of the knee carries the body down with control. When one lifts an object, the elbow's hinge converts muscular energy into precise leverage. The fingers, too, express this duality, firm enough to hold, gentle enough to release. The beauty of hinge joints lies in their restraint. They do not strive for excess. They perform exactly as much movement as needed, and no more. As with all parts of the body, hinge joints change over time. In youth, they are supple and forgiving, the cartilage thick and smooth, the ligaments pliant. With age or strain, they may stiffen, the fluid diminish, the surfaces roughen, yet their endurance remains remarkable. For decades, they carry out their work in silence, bending and straightening millions of times without failure. They respond to care, to motion that is steady and balanced, to strength built gradually rather than forced. They remind us that maintenance, in the body as in life, depends on balance and gentleness. To reflect on the hinge joints is to appreciate the elegance of simplicity. They do not boast of complexity, yet within their humble design lies the foundation of nearly every physical act. They let the body fold and extend, rise and descend, reach and return. They turn strength into grace and effort into ease. In every quiet bend of the elbow, every patient step of the knee, every subtle curl of the hand, the hinge joints reveal their artistry. They show that movement does not need to be elaborate to be beautiful, that precision, when guided by balance, becomes its own form of grace. And so, with every motion we make, whether grand or small, these simple hinges remind us that beauty often resides in the quiet rhythm of things well designed, in the effortless motion born of perfect restraint. 12. Pivot joints, the axis of rotation. Within the quiet machinery of the skeleton, there are joints that do not bend or sweep in great arcs, but instead revolve with subtle precision. These are the pivot joints, the small but essential axes of rotation that allow the body to turn, twist, and orient itself in space. They may not command the same attention as the grand movements of the shoulder or knee, but without them, our world would become strangely still. The ability to turn the head, to rotate the forearm, to glance over one's shoulder, or to adjust the direction of a gesture, all of these small miracles depend upon the pivot joints. They are the turning points of motion, quiet centers around which the body revolves. A pivot joint is simple in structure, yet profound in function. One bone, shaped as a cylinder or peg, fits into a ring, formed partly by another bone and partly by surrounding ligaments. This arrangement allows rotation around a single central axis. The motion is not broad or sweeping. Instead, it is circular and continuous, like the turning of a wheel within its hub. Such joints are designed for precision, not range, and their purpose is to permit controlled rotation rather than flexibility in all directions. Through this elegant limitation, they provide the subtle movements that keep the body aligned and balanced. The most famous of these joints lies at the very top of the spine, where the head meets the neck. It is the joint between the first and second cervical vertebrae, the atlas and the axis. The names themselves evoke their function. The atlas, named after the mythic figure who held the heavens upon his shoulders, supports the weight of the skull. The axis, lying just below, provides the pivot around which the head turns. The unique shape of the axis includes a bony projection called the odontoid process, or dens, which rises upward into a ring-like structure within the atlas. Strong ligaments encircle it, forming a stable loop that allows the head to rotate from side to side. Every time you turn to look over your shoulder, nod gently, no, or scan the horizon. This quiet joint performs its task. It is a movement so smooth and familiar that we rarely think of the intricate design that makes it possible. The relationship between the atlas and the axis is one of both freedom and protection. The joint must allow the head to rotate easily, but it must also safeguard the delicate spinal cord passing just behind it. The ligaments here are extraordinarily strong, ensuring that motion remains within safe limits. Too much rotation could endanger the vital structures within, but within its designed range, it is a masterpiece of controlled motion, a ring turning around a single peg, guarded and guided by the strength of living tissue. Another example of a pivot joint can be found in the forearm, where it grants the ability to rotate the hand without moving the upper arm. The two long bones of the forearm, the radius and the ulna, run side by side. At both the elbow and the wrist, they are connected by pivot-like joints that allow the radius to rotate around the ulna. This motion, known as pronation and supination, is what enables the palm to turn upward or downward. It is an action so common that we perform it hundreds of times a day, turning a key, twisting a doorknob, pouring a cup, or opening the hand to receive something. Without this quiet rotation, the hand would lose much of its versatility and expression. The forearm would move as a rigid beam, and countless gestures would become impossible. The pivot joints here transform stiffness into grace. The design of these joints reflects nature's gift for economy. They achieve complex function with minimal structure, instead of large surfaces gliding over one another, as in the ball and socket joints. Its movement is circular but contained, offering freedom within boundaries. This efficiency allows for fine control. In the neck, it lets the head turn smoothly without disturbing the alignment of the spine. In the forearm, it allows the hand to rotate without shifting the position of the elbow. The tissues that support these joints are small but remarkably strong. Surrounding ligaments hold the rotating bone tightly within its ring, maintaining alignment while allowing motion. The articular surfaces are covered with cartilage, as in other synovial joints, providing smoothness and reducing friction. Within the capsule, synovial fluid flows and nourishes the tissue, ensuring that every turn happens in silence. The muscles that produce the rotation are equally specialized. In the neck, small, deep muscles near the base of the skull coordinate the rotation of the atlas and axis. In the forearm, the pronator and supinator muscles wrap around the bones in gentle spirals, their contraction producing a quiet twist that turns the palm. The very architecture of these muscles reflects their purpose: spiraled, efficient, and continuous. The pivot of the neck gives us our sense of orientation, allowing our eyes and ears to explore our surroundings. The simple act of turning the head embodies freedom, a gesture of curiosity and attention. In the forearm, the pivot joints extend that freedom to the world of touch and creation. The hand's ability to manipulate tools, to hold, to turn, to express, all depend on that quiet rotation between the radius and ulna. Every act of painting, writing, pouring, or threading a needle relies on this delicate movement. In their subtle turning, the pivot joints become the physical foundation of exploration and interaction. Even in stillness, they remain poised for motion. When you hold your head upright, the atlas and axis maintain a balanced tension, ready to respond to any shift in focus. When your hand rests on a surface, the forearm's rotation adjusts minutely to distribute pressure evenly. These micro-movements, almost imperceptible, prevent fatigue and keep the joints healthy. They ensure that motion, when it comes, is smooth and effortless. The pivot joints, though small, contribute to the body's constant adaptability, its readiness to move, to observe, to act. Like all living structures, these joints depend on movement for maintenance. When they are used gently and regularly, the flow of synovial fluid remains steady, the cartilage nourished, the ligaments supple. When they are held too long in stiffness or strain, their fluid thickens and their tissues grow less elastic. Even the act of turning the head slowly or rotating the wrist softly keeps them alive, their small circles renewing the life within. Through movement that is calm, continuous, and balanced, the pivot joints carry a quiet symbolism as well. They represent the body's ability to change direction, to look anew, to adapt, to reorient itself without losing balance. They are the physical embodiment of turning points, those moments when one chooses a new perspective or a new path. Their motion is not wide or dramatic, but focused and intentional. It speaks of awareness, of the gentle art of adjustment that sustains life in both body and mind. To contemplate the pivot joints is to appreciate how the body's design achieves grace through restraint. They do not seek the sweeping range of the shoulder or the power of the knee. Instead, they refine movement to its purest form: rotation around a single, steadfast axis. Within their circles lies precision, balance, and the quiet intelligence of adaptation. They remind us that motion need not be grand to be profound, and that within the smallest turns, life expresses its most enduring elegance. Through them, the skeleton reveals one of its greatest truths: that strength is not only the power to move forward, but also the wisdom to turn gently, to adjust, and to remain centered in motion. 13. Condyloid and saddle joints. Precision in motion. Among the many ways the skeleton moves, there are some joints that do not boast the great arcs of the shoulder or the firm hinge of the knee, but instead perform a subtler dance movements of grace, delicacy, and control. These are the condyloid and saddle joints, the quiet artisans of motion. They are the architects of fine adjustment, the reason a hand can trace a line or a head can tilt in thoughtful nod. Their movements are measured, small, and intricate, yet within them lies a level of precision that defines much of what makes human motion so refined. They do not call attention to themselves, for their work is quiet and exact. Gestures. The condyloid joint, also called an ellipsoidal joint, allows motion in two planes, forward and backward. It takes its name from the rounded, oval shape of one bone's surface, the condyle, which fits into a shallow depression of the adjoining bone. The shape resembles a small, smooth knuckle resting in a softly curved socket. This design permits flexion, extension, abduction, and adduction movements that can blend into gentle circular motions called circumductions. The wrist, for example, is a classic condyloid joint. Every time the hand tilts forward in greeting, bends backward in balance, or shifts subtly from side to side. It is this joint that makes it possible. Unlike the ball and socket, it cannot spin freely, and unlike the hinge, it cannot move only in one plane. It occupies the middle ground, a joint of precision rather than power, of control rather than freedom. In the wrist, the condyloid structure lies between the radius of the forearm and the carpal bones of the hand. It is here that the hand gains its ability to adapt its angle to every task, to write, to catch, to lift, to rest. The motion may seem effortless, but beneath the surface, a delicate balancing act unfolds. Tendons glide over bone, small muscles adjust their tension, and ligaments guide the path of movement so that each gesture remains smooth and true. The condyloid joint is a sculptor's tool in the anatomy of motion, shaping the subtle curves of every human act. Another fine example of a condyloid joint can be found in the jaw, at the temporomandibular joint, where the lower jaw, or mandible, meets the temporal bone of the skull. This joint allows the mouth to open and close, to shift slightly from side to side, and to move forward and backward. These small but complex motions enable speech, chewing, and expression. When we smile or whisper, when we chew a piece of food or yawn deeply, the condyloid mechanics of the jaw are at work, translating muscular energy into smooth, gliding motion. The design of this joint also includes a small disc of cartilage that cushions and guides the movement, ensuring that each action remains both fluid and controlled. It is a joint of conversation, of nourishment, and of expression, perhaps the most human of all. The saddle joint, meanwhile, is rarer and more specialized. Its shape resembles the meeting of two saddles placed perpendicular to one another, each surface concave in one direction and convex in the other. This unique structure allows movement in two planes, much like the condyloid joint, but with slightly greater range and an unusual combination of stability and freedom. The most famous saddle joint in the body lies at the base of the thumb, where the first metacarpal bone meets the trapezium of the wrist. It is this joint that gives the thumb its remarkable versatility, the ability to oppose the fingers, to grasp. The hand gains its individuality, its dexterity, its power to shape and to create. To watch the thumb in motion is to witness the quiet genius of the saddle joint. With a simple curve or tilt, it can meet any of the fingers, forming countless variations of grip and touch. The same joint that allows a child to hold a pencil with curiosity also allows a craftsman to guide a fine tool with precision, or a musician to draw melody from strings. The saddle joint grants humanity its defining gestures, the clasp of hands in greeting, the gentle hold of care, the subtle adjustments that turn a thought into action. The movement is not large, but it is infinitely expressive. It is as though within that small space, the body found a language more eloquent than words. What unites the condyloid and saddle joints is their devotion to control. Both operate through limited but coordinated motion, translating the strength of muscles into precise adjustments. Their structure reflects this purpose. The articular surfaces are shaped not for sweeping arcs, but for gliding, elliptical shifts that maintain constant contact. Cartilage cushions each surface, and synovial fluid fills the space between, allowing motion without friction. Ligaments surround the joint, firm enough to maintain alignment but loose enough to permit the desired movement. Every detail serves the balance between stability and expression, a joint that neither locks nor wobbles, but glides, poised between strength and grace. These joints teach the body refinement. They make it possible to perform tasks that require care, the slow turning of a page, the delicate lifting of a cup, the measured tilt of the head in thought. They bridge the gap between gross movement and fine motion, between power and delicacy. Without them, our actions would be blunt, our gestures coarse. They give life to the subtlety of movement that defines human behavior. They are the reason a hand can express emotion as clearly as the face, tenderness in touch, precision in work, stillness in rest. The receptors within their capsules constantly monitor pressure, position, and movement, sending signals to the brain that fine-tune coordination. This feedback ensures that each motion is precise, whether it involves balancing a drop of ink on a brush or adjusting posture in sleep. The condyloid and saddle joints are the instruments through which the mind's intention becomes the body's articulation. Every refined action, every careful motion, flows through their quiet mastery. Over time, these joints, like all others, bear the marks of use. The cartilage may thin, the fluid may change in consistency, and the movements may lose their youthful ease. Yet even as they age, they remain faithful, continuing their work through countless repetitions. The wrist bends and steadies, the thumb adjusts and grasps, the jaw opens and closes a rhythm that continues through every day of life. When they move gently and often, they remain supple, nourished by motion, and protected by the very activity they enable. It is through use that they stay alive. The condyloid joint creates the smooth ellipses of motion that keep our actions fluid and balanced. The saddle joint brings forth the gestures that define individuality and care. Together, they show how the human form finds elegance not in grand movements, but in small, precise ones. They are the quiet translators of thought into motion, of intention into touch. In their delicate rotations and glides, we find the essence of grace, the art of control, without rigidity, motion without chaos. They remind us that mastery, whether in the body or in life, is found not in excess but in balance. Through their refined design, the condyloid and saddle joints allow us to inhabit the world with both strength and sensitivity, transforming anatomy into poetry. They are the unseen artists of every gesture, the subtle sculptors of human motion, forever tracing, in the air and in the heart, the fine and silent line between power and tenderness. 14. Gliding joints, quiet sliding, beneath the surface. There are joints within the body, so discreet, so subtle in their function, that one could live a lifetime without consciously noticing them. They do not perform grand movements or sweeping arcs. They do not lift, twist, or rotate with power. Instead, they slide, they shift gently, almost imperceptibly, allowing the body to remain supple and whole. These are the gliding joints, the quiet connectors hidden deep within the skeleton. They are the smallest and calmest of all joints. Yet they are everywhere, stitching together the body's framework with fluid ease. It is through their silent cooperation that posture is maintained, balance preserved, and the tiniest adjustments made to every larger motion. A gliding joint, also known as a plane joint, is formed where two relatively flat or slightly curved surfaces of bone meet. Instead of one fitting into another like a socket or hinge, these bones rest against each other like smooth stones in a gentle stream, moving through a thin layer of synovial fluid. The movement they allow is small, mere millimeters, at times yet endlessly important. It is this micromotion that lets the wrist flex gracefully, the ribs expand with each breath. Though they may appear still to the eye, they are always alive with subtle shifts, the invisible motion that keeps the body's larger structure stable. The wrist is home to some of the most intricate examples of gliding joints. Between the carpal bones, those 8 small, pebble-like bones arranged in 2 rows, countless tiny articulations occur. Each carpal bone slides gently against its neighbor, shifting slightly as the hand bends, twists, or presses. The same occurs in the ankle, where the tarsal bones glide over one another, distributing weight and adjusting the angle of each step. These movements are so delicate that they are almost inaudible to the senses. Yet they are the foundation of the body's adaptability. When the hand molds itself around an object, when the foot conforms to uneven ground, it is the gliding joints that allow this quiet accommodation. In the spine, gliding joints perform one of the most vital roles of all. Between each vertebra lie small joints called facet joints, where flat surfaces of bone meet and slide against one another. These joints guide and limit motion in the back, allowing the spine to bend and twist without losing alignment. They share the work with the intervertebral discs, distributing pressure and maintaining balance. Every turn of the head, every soft bow of the back, every small shift in posture as one breathes or lies in rest, all are supported by the distant skill, continuous, coordinated sliding of these gliding joints. Though their movement is minimal, their collective effect is immense. They transform the spine from a rigid column into a flexible yet stable pillar of life. What defines the gliding joint is not range, but fluidity. Unlike other joints that have clear arcs of motion, these joints offer no fixed path, only the freedom to shift in response to surrounding forces. They adapt constantly, responding to gravity, to muscle contraction, to the subtle play of breath. Their surfaces are covered with a thin, polished layer of cartilage, designed to minimize friction. Between them lies synovial fluid. As one moves, pressure changes cause this fluid to spread evenly across the surfaces, maintaining the ease of motion. Even in stillness, microscopic movements circulate the fluid, keeping the tissues healthy. It is a system of perpetual quiet adjustment, one that continues, whether we are aware of it or not. The simplicity of the gliding joint belies its complexity. Each one is part of a greater network, influenced by the movement of others. When the wrist bends, the gliding joints of the carpal bones shift in small synchrony, their collective sliding producing the smoothness of motion. When one twists at the waist, the facet joints of the spine adjust their angles in harmony, preventing strain and maintaining alignment. The body is full of these hidden collaborations. They ensure that no single structure bears too much burden, that forces are distributed evenly, and that motion flows without interruption. Through their cooperation, the body achieves balance not through rigidity, but through constant, minute adaptation. There is something profoundly calming in the idea of these joints always in motion, yet never dramatic. They speak of a kind of wisdom that values subtlety over force, continuity over spectacle. The gliding joints remind us that stability is not the absence of movement, but its quiet refinement. They keep the body from becoming brittle by allowing the smallest degrees of freedom in places that might otherwise be locked. In doing so, they protect the larger joints and bones from strain. Without them, the skeleton would creak and fracture under the stress of life's constant demands. With them, the entire body moves as one fluid organism, resilient and enduring. Their movements are so small that they exist in the space between the two, neither fully motionless nor visibly active. They embody the subtle rhythm that lives beneath all bodily function, the quiet pulse of life itself. Even when one lies at rest, these joints are at work, shifting microscopically with every breath, maintaining alignment as muscles relax. They are the silent caretakers of posture, preventing stiffness and ensuring that stillness never becomes stagnation. In the ribs, gliding joints connect each bone to the sternum and to the vertebrae of the spine. Every breath we take depends on their cooperation. As the lungs expand, the ribs lift and widen slightly, and the gliding joints allow that small but essential movement. When we exhale, they settle back again, their motion reversing with perfect precision. Breathing, the most constant act of life, depends on their quiet labor. Without their small slides, the chest would be rigid, unable to follow the rhythm of respiration. The air that enters our lungs is guided by the motion of these unseen joints, moving in harmony with the rise and fall of the breath. The durability of gliding joints is one of their most admirable qualities. Because their motion is gentle and evenly distributed, they experience little wear. The cartilage remains smooth for many years, nourished by the flow of synovial fluid. Their simplicity ensures endurance. They are built to last. Yet, like all parts of the body, they benefit from movement. Gentle stretching, breathing, and regular activity keep them supple. It is through motion, even the smallest, that they maintain their health. When movement ceases, the fluid thickens, and stiffness begins. When movement returns, fluidity is restored. The gliding joints, in their humility, teach the body the importance of continuous, effortless motion, not as exertion, but as quiet maintenance of life. There is poetry in the way they operate without drawing attention. Their sliding goes unnoticed, yet it shapes the grace of every larger action. They allow the dancer's spine to curve, the craftsman's wrist to adjust, the sleeper's body to rest in comfort. They make the grand gestures of the body possible by ensuring that the small movements beneath them remain seamless. In their stillness lies motion, and in their motion lies stillness, a paradox that mirrors the deeper rhythm of life itself. To contemplate the gliding joints is to recognize the beauty of subtle function. They do not command, they support. They do not strive for attention. They enable everything else to move freely. Their silence is their contribution, their invisibility, their strength. They remind us that the smallest things often carry the greatest significance, that the most delicate movements sustain the grandest forms of motion. Beneath the visible grace of the body's gestures lies this quiet world of sliding, shifting, and adjusting, a world that never rests, yet never rushes. And so, in the hidden depths of the skeleton, the gliding joints continue their endless work. They slide beneath the surface, uncelebrated but indispensable, transforming rigidity into fluidity and stillness into balance. They are the body's whisper, the constant, gentle sound of life keeping itself in motion. Through them, the human form finds its poise, its endurance, and its peace. 15. The support network, ligaments, tendons, and cartilage beneath. The motion of every joint. Beneath the grand arcs and the smallest slides, there exists a hidden network of support, a system of fibers and tissues that holds the body together while allowing it to move freely. This intricate network is made of ligaments, tendons, and cartilage. They do not move on their own, yet without them, movement would be impossible. They are the quiet stabilizers, the unseen strength that keeps bones aligned and muscles anchored. They are the silent conversation between strength and softness, the connection that makes motion safe, balanced, and fluid. Ligaments are the steadfast guardians of the skeleton. They are strong, fibrous bands that connect bone to bone, crossing the joints like invisible cords. Each one is built for endurance, composed mainly of dense bundles of collagen fibers woven together in parallel lines, giving them the ability to resist stretching and tearing. They hold the bones firmly in place, preventing dislocation while still allowing the permitted range of motion. In every joint, from the shoulder to the ankle, ligaments act as the faithful boundaries that keep freedom in check. When you extend your arm or bend your knee, It is the ligaments that quietly decide when to stop. They do not resist abruptly but yield with soft tension, guiding movement to its natural limit and returning it gently to rest. In the knee, for instance, four major ligaments form a complex web of control. The anterior and posterior cruciate ligaments cross within the joint like the cords of an inner bridge, holding the femur and tibia in perfect alignment as the leg bends and straightens. Along the sides, the collateral ligaments steady the knee against unwanted shifts. Each movement you make, whether walking or kneeling, is monitored by these fibrous sentinels. They never tire, never cease to hold, even as you rest. They are not made to move dramatically. Their purpose is to maintain order within motion, to ensure that grace never becomes instability. Around the shoulder, the ligaments are looser, allowing the wide freedom that defines the ball and socket joint. Yet even here, they remain vigilant, tightening at the edges of movement to prevent the arm from straying too far. They are flexible yet firm, soft yet unbreakable under ordinary strain. Their strength is not in force but in constancy. They are the structures that endure quietly, their fibers renewing slowly but faithfully, maintaining the stability of every gesture and stance. Tendons, though similar in composition, perform a different but equally vital role. If ligaments hold bones to one another, tendons connect muscle to bone, translating muscular contraction into motion. They are the messengers of movement, transmitting force from the living tissue of muscle to the unyielding structure of bone. When you reach, lift, or step, it is the tendon that carries the will of the muscle into action. They are cords of energy and connection, strong and flexible, composed of tightly packed collagen fibers arranged in elegant spirals. Each tendon is designed to withstand tension, stretching slightly as muscles pull, then recoiling as the motion ceases. The Achilles tendon, for example, is one of the most powerful in the body. It connects the calf muscles to the heel bone, allowing the body to rise, jump, or walk. With each step, it stores energy like a spring and releases it with gentle precision, turning effort into motion. The tendons of the hand, by contrast, are small and intricate, gliding through narrow sheaths lined with synovial fluid. They allow the fingers to curl, the hand to grasp, and the wrist to flex. When a musician plays an instrument, when a writer moves a pen, when a craftsman shapes a tool, it is the quiet glide of tendons that makes such subtle movement possible. Tendons, like ligaments, are living tissues. They have a slow metabolism, nourished by both surrounding blood vessels and the motion that keeps them active. When used gently and regularly, their fibers remain supple. When neglected, they stiffen and lose elasticity. They are strengthened through balance, not through strain, but through steady use. This delicate equilibrium between tension and rest mirrors the rhythm of life itself. The tendons hold within them the record of our movements, their fibers adapting quietly to every gesture and every step, growing stronger in response to care. Cartilage, the third element of this support network, serves as the body's cushion and shape giver. It is a form of connective tissue, yet unlike ligaments or tendons, it is smooth and almost glass-like. Its surface glistens with a faint sheen when healthy, and its texture is both firm and yielding, much like dense rubber softened by warmth. Found at the ends of bones, in the nose, the ears, the ribs, and within the joints, cartilage gives structure where flexibility is required. It absorbs shock, distributes pressure, glide without friction. Without cartilage, every movement would be harsh and painful. Bone would meet bone in grating resistance. It is the silent buffer that transforms pressure into ease. There are different kinds of cartilage, each suited to its task. Hyaline cartilage, the most common, lines the ends of bones at joints, forming the smooth articular surfaces that make movement frictionless. Its transparency and smoothness are so perfect that it has been described as living glass. Fibrocartilage, found in intervertebral discs and the pubic symphysis, is tougher and more fibrous, designed to resist compression and tension. Elastic cartilage, found in the ear and epiglottis, combines strength with flexibility, allowing shape to return even after bending. Each type reflects the body's ability to tailor structure to function, turning simple materials into forms of quiet perfection. Cartilage is nourished differently from most tissues. It contains no blood vessels of its own. Instead, it depends on the flow of synovial fluid and the gentle pressure of movement to sustain it. Movement, therefore, is not just an expression of life but a requirement for it. In stillness, cartilage starves. In motion, it thrives. The quiet rhythm of use keeps it smooth and strong, ensuring that every joint continues its effortless function. Together, ligaments, tendons, and cartilage form the trinity of joint support, the structural harmony that makes motion possible. Ligaments set the boundaries, tendons provide the action, and cartilage ensures smoothness. Each depends on the others. Without ligaments, joints would collapse into disarray. Without tendons, muscles would have no means of exerting their force. Without cartilage, even the smallest motion would bring friction and pain. Yet when they work in unison, they create a system of breathtaking efficiency, a living mechanism that balances tension and release, firmness and flow. There is a kind of poetry in their cooperation. The ligaments, strong and stoic, hold the framework steady. The tendons, dynamic and elastic, translate motion into grace. The cartilage, soft and silent, turns resistance into ease. Together, they embody the essence of stability through movement. They are the body's quiet engineers, unseen but essential, transforming anatomy into art. When we rest, they do not sleep. The ligaments maintain gentle tension. The tendons preserve their readiness. The cartilage continues its subtle exchange with surrounding fluids. Even in stillness, their life endures. They hold the memory of movement within their fibers, waiting for the next gesture, the next step, the next breath. They are not only physical structures but symbols of the body's resilience, the threads that weave motion, strength, and harmony into one. To reflect on this support network is to understand the balance that sustains life itself. Every movement we make, every stillness we hold, depends upon their quiet strength. They teach that endurance is not born from rigidity but from flexibility, that strength lives in adaptation, and that the gentlest materials often bear the greatest responsibilities. Through them, the skeleton moves without falling apart, and the body endures without losing grace. Ligaments, tendons, and cartilage, these are the silent companions of every motion, the soft architecture of the body's grace. In their harmony, we find the very essence of living structure, strong yet supple, enduring yet alive, capable of bearing weight and still responding to the slightest breath of motion. They are the whispering framework beneath every act, holding life in a balance so perfect that we seldom notice it, the quiet, eternal strength that lets the human body move through the world with both power and peace. 16 joints in the nervous system. Joint in the human body, no matter how large or small, exists in conversation with the nervous system. Movement is never an isolated event. It is a continuous exchange between sensation and action, between intention and response. The bones and tissues may form the structure of a joint, but it is the nervous system that gives it awareness, the capacity to sense position, to adjust pressure, to move with grace rather than chaos. The nervous system is not simply a controller. It is a silent partner that listens and reacts, guiding every joint in a choreography so fluid and constant that it becomes invisible. This hidden communication between nerves and joints is one of the most exquisite examples of biological harmony, a balance of motion, perception, and care. To understand this relationship, imagine the simplest of actions: bending a finger, turning the head, or taking a single step. Before the body moves, the brain has already made countless calculations: the angle, the speed, the tension of muscles, the weight that will shift from one joint to another. Nerve impulses travel from the brain through the spinal cord, branching out into the limbs to activate muscles. The tendons pull, the ligaments hold, and the bones respond. Yet this is only half of the story. As the movement occurs, another stream of information flows in the opposite direction from the joints back to the brain. Tiny sensory receptors embedded in the tissues send constant updates about position, pressure, and stretch. It is this returning stream of data that allows the brain to fine-tune every motion in real time, ensuring balance, precision, and ease. Within every joint are specialized nerve endings that serve as the body's sentinels of awareness. Some of these receptors, known as mechanoreceptors, detect changes in pressure or tension. Others, called proprioceptors, monitor the position and movement of the joint. Together, they form the foundation of proprioception, the body's innate sense of where it is in space. It is through proprioception that we can close our eyes and still touch our nose, that we can walk without watching our feet, that we can maintain balance even in darkness. The joints are constantly informing the brain of their position, even in stillness. They whisper in a language of signals, subtle but precise, mapping the body's orientation in the world moment by moment. These receptors are found in abundance in the ligaments, capsules, and surrounding muscles of each joint. When a joint bends or stretches, the receptors fire, sending electrical messages through sensory nerves to the spinal cord and then to the brain. The brain interprets these signals instantly, adjusting muscle activity to protect the joint or refine its motion. This process happens faster than conscious thought. If you stumble, your joints and muscles correct your balance before you have time to realize what happened. If a joint moves too far or too quickly, the receptors trigger reflexes that tighten the surrounding muscles, preventing injury. The communication is continuous, an endless dialogue that maintains safety and control with every step, every gesture, and every quiet breath. In this way, the nervous system acts as both guardian and guide. It ensures that movement remains within the joint's safe limits, and it modulates the force of muscles to protect the delicate tissues. Without this feedback loop, our movements would be jerky and uncertain, like a puppet with tangled strings. It is the nervous system's constant monitoring that allows motion to become smooth and responsive, adapting effortlessly to changing conditions. When you reach for an object, your joints and brain cooperate in an intricate exchange. The hand adjusts its angle, the wrist balances tension, the shoulder stabilizes. This happens not through conscious effort, but through the quiet intelligence of the body's own sensing system. The integration of the nervous system and the joints extends far beyond simple motion. It is also essential to posture, coordination, and the sense of balance. Deep within the inner ear lies the vestibular system, which detects orientation and movement of the head. This information merges with signals from the joints of the neck, spine, hips, and ankles to create a complete sense of equilibrium. When you stand, your joints make constant microscopic adjustments, guided by the nervous system to keep you upright. Even in perfect stillness, the body is never truly at rest. Tiny movements flow through the joints as they respond to gravity, breath, and subtle shifts in weight. It is a living balance, not a frozen stillness, but a continuous adaptation orchestrated by nerves and muscles in unison. Pain, too, is part of this communication. Within the joints are nociceptors, specialized receptors that sense potential harm. When tissue is strained or inflamed, these receptors send warning signals to the brain. Pain, though unpleasant, is a form of protection, a message urging stillness and care. It prevents further damage by calling attention to what the body cannot endure. The sensitivity of joints varies. Those that bear weight or perform complex movements, like the knees and shoulders, are richly supplied with nerves. Through this sensory network, the joints not only move but also express their needs. They tell the brain when to rest, when to shift, when to heal. The nervous system also influences how joints heal and adapt. When an injury occurs, nerve signals trigger the release of substances that promote inflammation and repair. The same communication that coordinates movement now guides recovery, summoning immune cells and directing them to rebuild damaged tissue. Over time, as healing progresses, the nervous system recalibrates its sense of movement, reteaching the joint how to operate smoothly again. This process requires patience and motion, gentle, deliberate movement that restores the natural dialogue between nerve and tissue. The healing joint must relearn how to listen and how to respond. Emotion and awareness play their part as well. The body's nervous system responds not only to physical movement but also to the mind state. Stress, fear, or tension can cause muscles around joints to tighten, limiting their motion and altering the feedback they send to the brain. Conversely, calmness and relaxation encourage smooth, coordinated movement. When one breathes deeply, when the mind grows still, the nervous system softens its grip, and the joints move more freely. This link between body and mind is not metaphorical. It is physiological. The same nerves that guide motion also respond to emotion. The harmony of movement depends on the harmony of thought and feeling. When we move gracefully, it is because this entire system, bones, joints, nerves, muscles, works together in seamless unity. The nervous system listens to the joints, and the joints listen back. It is a dialogue without words, a symphony of signals so precise and immediate that it feels like instinct. In truth, it is deeper than instinct. It is the embodiment of awareness, the intelligence of the body expressing itself through motion. Even in rest, this relationship continues. As we sleep, the nervous system slows but does not stop. Tiny adjustments occur unconsciously to maintain comfort and protect the joints from strain. The body remembers its alignment, guided by the same signals that steer it during waking motion. The dance of nerve and joint never ceases. It merely softens its rhythm, like an orchestra quieting into a lullaby. To contemplate this connection is to see that movement is not a mechanical act but an expression of harmony between structure and sensation. The joints are not lifeless hinges. They are living instruments tuned by the nervous system. Every step is a note, every stretch a phrase in the music of motion. The nerves guide and correct, but they also listen and adapt. Through this living conversation, the body achieves balance without conscious command. It is a perfect example of how intelligence is woven into every fiber of life, not as thought, but as awareness, as quiet, knowing. In the union of joints and the nervous system, we find the essence of embodied grace, the seamless link between motion and mind, between sensation and stillness. They remind us that movement is more than mechanical function. It is a form of awareness, a dialogue between self and world that never truly ends. Every turn, every step, every gesture is guided by this silent communication. It is a dance of knowing and responding, of holding and releasing, of tension and ease. Through it, the human form finds not only balance, but understanding, the kind of wisdom that lives not in words, but in motion itself. 17. The aging of joints. As the years move quietly through a human life, they leave their soft imprint upon the body. The hair changes color, the skin grows thinner, and deep within, the joints, those faithful instruments of motion, begin their slow transformation. The aging of joints is not a sudden event, nor is it merely a process of decline. It is a gradual reshaping, a reflection of time's passage through the living framework of the skeleton. Like the slow weathering of stone by wind and water, it speaks not of destruction, but of endurance. To understand how joints age is to appreciate the balance between motion and rest, the way life continues to express itself even as it changes its form. From youth to old age, the joints serve as the body's quiet companions in every motion. In childhood, they are supple and rich with fluid, the cartilage smooth and resilient, the ligaments elastic, the bones still growing and adapting. Movement comes easily, almost thoughtlessly, as if the body itself were light. The synovial fluid flows freely, clear and abundant, cushioning each movement with effortless grace. The articular cartilage, that glistening layer covering the ends of bones, is thick and firm, a perfect surface for frictionless motion. In youth, the joints are silent and strong, and motion is their native language. But as the decades pass, the rhythm of renewal begins to slow. The cells that once replenished cartilage and fluid work more slowly. The smooth surfaces that once gleamed like glass begin to lose their sheen, becoming a little thinner, a little less elastic. This thinning of cartilage does not happen all at once. It occurs quietly, imperceptibly, over years. With every movement, the cartilage absorbs pressure and distributes force, and though it regenerates, it does so with less vigor than before. The once spongy cushion becomes firmer, less hydrated, more fragile. The same is true for the synovial fluid, which gradually loses some of its viscosity. The fluid remains, still serving its vital purpose, but its silky smoothness diminishes. The glide of bone against bone, once effortless, begins to feel the faintest trace of resistance. The ligaments that hold the joints together also change. Made primarily of collagen, they are living fibers that rely on constant renewal. In youth, they are supple and responsive, able to stretch slightly and return to their original length. With age, the collagen fibers become less flexible, more rigid in their alignment. This stiffness limits motion but also provides stability. The joints, once fluid and expansive, become more deliberate, their movements smaller but steadier. There is a wisdom in this, a quiet conservation of energy. The body adapts, finding new rhythms that suit its changing materials. The tendons, too, grow more fibrous over time. They continue to transmit the pull of muscle to bone, but their elasticity fades. This is why older bodies move differently, not necessarily weaker, but slower, more mindful. The quickness of youth gives way to the measured cadence of experience. Each movement is performed with greater awareness, less waste, and often more grace. The body, in its quiet intelligence, learns to move within its limits rather than against them. Inside the joints, the bone itself undergoes change, the constant remodeling that defines bone. The continuous cycle of resorption and renewal also slows with age. In places where the cartilage thins, the bone may begin to bear more of the load directly. To adapt, it strengthens in patches, forming small outgrowths called osteophytes. These are not flaws, but compensations, attempts by the body to maintain stability. The joints that bear the most weight, the knees, hips, and spine, show these changes most clearly. They are the great pillars of motion, and they bear life's burdens quietly for many years. As these transformations unfold, the joints continue to serve faithfully, even when stiffness creeps in during morning hours, even when the pace of movement slows. They remain responsive to care. Gentle motion, warmth, and rest restore their ease. The body was never meant to remain still for long. Its health depends upon motion. When joints move, even in slow, measured ways, circulation improves, synovial fluid spreads across the cartilage, and the tissues are nourished. This is why movement remains one of the best healers through all stages of life. It is not the intensity of movement that matters, but its constancy, the quiet rhythm that keeps the body alive and aware. The experience of aging joints is also deeply sensory. One begins to feel the subtle resistance where once there was none, the faint stiffness that yields slowly to warmth. The joints speak more clearly with time, their sensations becoming reminders to listen, to rest, to move gently, to find balance between activity and stillness. They are not failing, they are communicating. Pain, in its truest form, is not an enemy, but a signal of care. It tells us to adjust, to soften, to nurture what has carried us so far. In this way, the aging of joints mirrors the aging of the person as a whole. It reflects a transition from speed to steadiness, from strength to sensitivity. The body learns to rely more on awareness and less on force. Where once movement was instinctive, now it becomes deliberate, even meditative. The slowing of the joints invites presence, a deeper attention to the act of moving, to the connection between mind and body. Walking becomes not merely transport but rhythm. Stretching becomes a form of listening. The aging joint, though less elastic, teaches the beauty of intention. There is also an adaptability in this process that should not be underestimated. The body is remarkably capable of adjusting to its changes. Muscles grow stronger around stiffer joints. Balance improves with awareness. New patterns of motion emerge that compensate for what is lost. In this way, the joints do not decline in isolation. They evolve as part of a living system that constantly seeks harmony. Even when age alters their form, their purpose endures. They continue to serve, to move, to support. Cartilage, though slow to heal, can still respond to care. The production of synovial fluid increases with regular use. Warmth and circulation can ease stiffness. Weight-bearing exercise strengthens the muscles and bones around joints, improving alignment and reducing strain. In this way, movement remains the key to longevity, not as exertion but as gentle continuity. Even the smallest actions, the turning of a wrist, the rising from a chair, the act of stretching in morning light, help preserve the life within the joints. Aging also deepens the appreciation of stillness. When the joints move more slowly, the pauses between movements gain meaning. One becomes aware of balance, of breath, of the quiet spaces within motion. The body learns patience, and the mind follows. The joints, having served through decades of motion, teach the value of ease of moving, not quickly, but well. They remind us that longevity is not about resisting change but embracing it, adapting gently to the rhythm of time. If one could look within an aging joint, one would see not failure, but evidence of life, lived fully. The surfaces that once bore the leaps and steps of youth now show the traces of endurance. The fibers of ligaments that held through years of labor remain strong. The bones, shaped by countless moments of pressure and release, continue their silent conversation with gravity. Every mark, every adaptation, tells a story of persistence. In the end, the aging of joints is not a loss, but a transformation. The body, though altered, retains its grace. It learns to move differently, but not less beautifully. The dance of life slows, yet its rhythm deepens. There is a quiet dignity in the way the body ages, a wisdom written not in words, but in motion, in the careful unfolding of each step, each gesture. The joints, though they stiffen, remain the instruments of that motion, carrying the person gently through the later movements of life's long, harmonious composition. 18. Preservation and healing. The joints, so long in service to every motion of life, are capable not only of enduring, but of renewal. Within their living structures lies a quiet wisdom, a system that knows how to repair, how to adapt, and how to preserve itself through time. Preservation and healing are not miracles imposed from without. They are the natural expressions of life, continuing its own rhythm. Every breath, every step, every stretch contributes to this ongoing restoration. To preserve the joints is not to fight against age or wear, but to move in harmony with what the body already knows, that motion, nourishment, rest, and balance form the foundation of vitality. Healing within the joints is a slow, patient process. Unlike the skin, which can mend quickly, or the muscles, which grow stronger within days of effort, the tissues of a joint operate at a gentler pace. The cartilage has no direct blood supply, and the ligaments and tendons receive limited nourishment. Their vitality depends on movement itself, the gentle pressure and release that circulates synovial fluid, carrying nutrients and removing waste. It is through motion that the joint breathes. When the body moves, the cartilage is compressed and released, drawing in nourishment like a sponge soaking water. When the body is still for too long, the flow diminishes, and the joint begins to stiffen. Thus, healing begins with motion, not strenuous activity, but soft, mindful movement that restores the rhythm of circulation. To preserve the health of joints is to cultivate this rhythm daily. It is not measured in intensity, but in consistency. Gentle stretching, walking, and slow, circular movements keep the synovial fluid alive within its capsule. Each motion refreshes the surfaces, keeping cartilage smooth and hydrated. Even small acts, rotating the wrists, flexing the ankles, bending the knees, softly signal to the body that it is still in use, still needed, still alive. The joints thrive when they are reminded of their purpose, when they are invited to move but never forced. In this way, care for the joints mirrors care for the spirit. Both respond best to gentle attention, steady nourishment, and patience. Preservation also depends upon alignment. The body was designed for balance, for even distribution of forces through the skeleton. When posture falters or movement becomes uneven, certain joints bear more strain than they were meant to carry. Over time, this imbalance can wear away cartilage or overstretch ligaments. To move with awareness, to stand tall, to sit evenly, to walk with measured steps is to honor the design of the body. It requires no constant correction, only the quiet habit of mindfulness. Is restored, effort decreases. The joints no longer labor to compensate for imbalance. Instead, they return to harmony. Preservation is, in essence, the art of moving as the body was made to move naturally, fluidly, without tension or haste. The nourishment of the joints extends beyond movement. Within the body, the materials that sustain cartilage and connective tissue are drawn from what we eat and drink. Collagen, the main structural protein of ligaments and tendons, relies on amino acids, vitamin C, and minerals such as zinc and copper. The synovial fluid, rich in hyaluronic acid, depends on hydration. Water is the simplest and most essential element of joint health. Every sip replenishes the quiet tides within the body, keeping the joints supple. Balanced nutrition, not excess, not deprivation, feeds the living tissues, allowing them to renew slowly but surely. Food, when seen in this light, becomes a form of medicine that sustains the body's quiet maintenance. Equally important is rest. The joints, though they thrive on motion, also depend on stillness for repair. In the absence of movement, energy shifts from activity to restoration. The synovial fluid redistributes, the tissues release tension, and microscopic repairs take place. The cartilage, relieved of constant pressure, draws in fluid to replenish itself. Rest and motion exist as partners, one to circulate life, the other to rebuild it. To neglect rest is to deprive the joints of their renewal. To neglect movement is to withhold their nourishment. True preservation lies in the rhythm between the two. Healing, when needed, is an extension of this same principle. The body's ability to recover from strain or injury depends not on speed, but on consistency and calm. When a joint is inflamed, the first step is quiet, allowing warmth, rest, and gentle protection. The nervous system, sensing safety, releases the tension that guards the injury, and circulation begins its work. In time, gentle movement returns, bringing life back to the tissues. Healing cannot be forced. It must be invited. The cells that rebuild collagen and cartilage respond best to steady, patient motion. A few degrees of bending, a small circle of rotation, repeated daily. The body understands gradual restoration far better than it does urgency. Mindful breathing often aids this process. The breath, though seemingly separate from the joints, influences them profoundly. When the breath is shallow and hurried, muscles tighten, pulling unevenly on the bones and restricting motion. When the breath deepens, tension softens, allowing the joints to move freely again. The oxygen carried by the breath nourishes every tissue, feeding the quiet repair beneath the surface. In this way, even stillness can become healing when accompanied by steady breathing, a reminder that life itself is rhythmic, alternating between expansion and release. Emotional states, too, leave their mark upon the joints. Stress can cause muscles to tighten unconsciously, pressing upon the joints and limiting their freedom. Worry can settle in the shoulders, tension in the jaw, weariness in the spine. To preserve joint health, one must care not only for the physical body but for the mind that inhabits it. Calmness, gratitude, and restfulness translate into relaxed muscles, smooth movement, and the gentle flow of energy throughout the frame. Healing, in this sense, becomes not only physical but holistic, the alignment of body, breath, and thought. As one grows older, the focus of preservation shifts. It becomes less about maintaining the speed or range of youth and more about keeping the body comfortable, balanced, and alive with ease. Gentle routines, stretching in the morning light, slow walks beneath the sky, quiet movements before sleep keep the joints open and warm. Even moments of mindful awareness during daily tasks, lifting with care, sitting with poise, pausing to stretch, become acts of preservation. Each one whispers to the body, reminding it that it is still cared for, still valued. There is no perfection in the life of a joint. Each one carries the marks of its history, the tiny frictions of years of motion, the slight changes in shape that come with age, the quiet adjustments made in response to strain. Yet within those marks lies beauty. The joints that have served long and faithfully speak of endurance and adaptation. Healing does not erase these marks. It honors them. Preservation does not seek to stop time. It walks gently alongside it, ensuring that motion remains possible, comfortable, and full of grace. When the body is tended in this way, the joints remain alive until life's end. They may not move as swiftly, but they move wisely, each motion deliberate, balanced, and peaceful. In their resilience, one can see the greater truth of life itself, that preservation is not the denial of change, but the embracing of it, that healing is not a return to what once was, but a continuation of what still can be. The joints, patient and enduring, mirror this truth in their quiet rhythm. With every small motion, they affirm life's ongoing harmony, a balance of strength and softness, effort and ease, persistence and rest. In the end, preservation and healing are not tasks to be accomplished, but ways of living. They are the art of listening to the body and responding with kindness, to move gently, to rest deeply, to breathe fully. These are the simple rituals that keep the joints and the life within them in motion. Through them, the body continues its silent work of renewal, and the miracle of movement endures calm, steady, and alive beneath the passage of time. 19. The symphony of motion. When the body moves, it does not move in fragments. Every motion, no matter how small, is a coordinated act, a symphony of countless parts, working together in perfect timing. Each bone, each ligament, each tendon, and muscle participates in the quiet orchestration that turns thought into action. The joints are the meeting places where these movements are translated into form. Within every step, every turn, and every gesture lies a harmony so intricate and constant that it becomes invisible. Yet, beneath this calm, the symphony plays endlessly, maintaining balance, flow, and life itself. To understand the symphony of motion is to see the body not as a collection of parts, but as one continuous instrument. The joints act as hinges and pivots, but also as bridges, connecting distant regions of the body through shared movement. When one joint moves, another adjusts. A step begins in the foot, but its rhythm travels upward through the ankle, knee, hip, and spine, and finally reaches the head, which balances to keep the gaze steady. The movement of a hand draws subtle responses from the shoulder, the chest, and even the breath. Acts alone. Every action is a thread in the fabric of motion, woven seamlessly through the body's living structure. The nervous system serves as the conductor of this symphony, sending impulses that travel faster than thought, synchronizing contraction and release. The muscles act as the instruments, producing motion with tension and tone. The bones are the framework of melody, providing the structure through which energy flows. And the joints, the silent spaces between, act as pauses and connections, allowing one movement to blend into the next without interruption. Their smoothness makes continuity possible. Without them, motion would be harsh and disjointed. With them, it becomes music. Each type of joint contributes its own note to this composition. The ball and socket joints provide the wide, sweeping phrases, the arcs of the shoulders and hips that give motion its expressive quality. The hinge joints add rhythm, the steady opening and closing that give structure and pace. The pivot joints add subtle turns and rotations, the gentle spirals that refine balance and direction. The gliding joints fill in the spaces between, adding smooth transitions that keep every gesture fluid. The condyloid and saddle joints offer nuance, precision, and the small articulations that make movement human and graceful. Together, they form a vocabulary of motion as rich and varied as any language, capable of expressing strength, delicacy, purpose, and rest. Within this constant motion lies balance, not a still point, but a living equilibrium. Balance is not the absence of movement, but the harmonious adjustment of countless micro-movements. When we stand upright, the body is never truly still. Tiny shifts ripple through the ankles, knees, and hips as the muscles make quiet corrections. The spine sways minutely, and the head adjusts above it like a compass finding true north. Each of these small movements occurs beneath awareness, guided by the senses and the nervous system. The symphony continues even when we believe we are at rest. The body maintains itself through motion, not through immobility. The rhythm of breathing is woven deeply into this symphony. Every inhale expands the chest, moving the ribs, stretching the cartilage, and adjusting the posture. Every exhale releases tension, softening the muscles and allowing the joints to settle. The diaphragm, that great internal muscle, moves downward and upward like the slow pulse of a drum, and the entire skeleton responds. The spine flexes slightly, the shoulders rise and fall, the subtle gliding joints of the ribs shift like the opening and closing of petals. Breathing is motion made rhythmical, an unending exchange between the outer world and the inner. It ties the mechanical act of movement to the deeper flow of life. The joints make this rhythm possible not through strength but through cooperation. Joint stiffens, the harmony falters, and other joints must compensate, often leading to strain. When flexibility and strength are balanced, motion regains its music, effortless, free, and whole. This is why care for the joints is care for the entire self. They are not isolated instruments, but the resonant chambers through which life's melody moves. In the symphony of motion, even stillness has a part. The moments between actions, the pauses, are as vital as the movements themselves. Just as music gains meaning through silence between notes, the body finds grace through moments of rest between motions. When one pose ends and another begins, the joints align in stillness, gathering the energy for what comes next. The still body is never lifeless. It is listening, gathering, preparing. This rhythm between motion and rest defines the harmony of all living things, the beating of the heart, the cycle of breath, the rising and setting of the sun. The joints, in their constant readiness, reflect this eternal alternation between movement and peace. Emotion, too, flows through this physical music. The body's movements are shaped not only by anatomy, but by feeling. Joy opens the joints, expands the chest, lightens the gait. Sadness narrows them, softens the spine, draws the shoulders inward. Tension and calm, fear and ease, each create a distinct pattern of motion. The symphony of the body is, in truth, a reflection of the mind's inner state. When calm returns, the joints loosen, the rhythm slows, the movements regain their quiet grace. In this way, emotion and motion are one, and the body becomes a mirror for the heart. The preservation of this symphony depends not on perfection, but on participation. To keep the body's motion alive, one must continue to move gently, consciously, regularly. Even the smallest movements keep the orchestra in tune. Continues. The body does not demand performance. It asks only for awareness. When we move with care, when we honor the joints with mindful motion, they respond with ease. The music deepens, becoming not an act of effort, but of harmony. In the quiet of reflection, one might imagine this symphony continuing even in stillness, the heart beating, the lungs rising and falling, the joints adjusting imperceptibly beneath the skin, the entire organism alive with motion, yet serene. This is the nature of life, motion within stillness, rhythm within silence. The joints, by their very design, embody this truth. They allow the body to move and to rest, to bend and to stand tall, to express and to be still. They are the hinges between the visible and the invisible, between the effort of life and the peace that sustains it. The symphony of motion never truly ends. It begins before birth, in the first small stirrings within the womb, and continues until the final stillness. Between these two points lies a lifetime of movement, walking, reaching, embracing, breathing, and being. Every motion is part of the same great composition, guided by the same subtle intelligence. The joints are its instruments, worn but resonant, responding to every note with fidelity. When we move with awareness, we participate in this music consciously, feeling its rhythm in our bones. In the end, the body's motion is more than mechanics. It is a language of connection. Through it, we interact with the world, with one another, and with ourselves. The joints, though silent, are the translators of that connection. They turn thought into gesture, intention into touch, awareness into movement. Their harmony with muscles and nerves is the embodiment of balance, not forced or rigid, but flowing, continuous, alive. To listen to this symphony is to understand the miracle of being, that life, in its essence, is not stillness but endless, graceful motion. 20. Reflection and stillness. The living architecture within, in the quiet spaces between movements, when the body comes to rest, there exists a profound stillness. Yet even within that stillness, the body remains alive with subtle motion. The heart continues its patient rhythm. The breath rises and falls, and the joints, though resting, make small, almost imperceptible adjustments to preserve comfort and balance. This is the body's natural meditation, a state of living stillness, where the architecture of the skeleton and the flow of the nervous system exist in harmony. It is here, in this space between action and repose, that one can truly see the beauty of the human form, not as a machine of parts, but as a living whole, a structure made of silence, motion, and awareness combined. The skeleton, often thought of as rigid and unchanging, is in truth a dynamic and responsive framework. Even when the body lies still, the bones bear the gentle weight of life, shifting minutely with every breath. The spine elongates and contracts with the subtle tides of inhalation and exhalation. The shoulders rise slightly as the ribs expand. The pelvis tilts gently as the air flows downward into the abdomen. These motions are almost invisible, yet they are real, the silent dance of equilibrium that never truly ceases. The joints play their role in this dance, adjusting their angles in harmony, allowing stillness to be alive rather than static. Stillness, then, is not the absence of motion, but its refinement. It is the moment when movement becomes so smooth, so balanced, that it transcends effort. To rest deeply is not to become inert, but to return to a state of perfect balance where all opposing forces within the body neutralize one another. The tension of muscles, the pull of ligaments, the weight of gravity, and the buoyancy of breath meet in quiet accord. The joints, released from strain, rest in alignment, and the body as a whole finds ease. It is in this state that healing often begins, for stillness allows the body to listen to itself, to recalibrate, to restore its harmony. In such stillness, the mind also softens. The awareness that was once scattered through constant motion begins to gather inward. When one sits or lies quietly, the mind can sense the body not as separate limbs, but as one continuous field of sensation. The faint pulse of the heart, the quiet support of the bones beneath the skin. The joints, though silent, can be felt as centers of connection, the meeting points of effort and release. This awareness, once noticed, brings a sense of unity. The body is no longer a collection of parts. It becomes an architecture of wholeness, where every structure supports every other. There is a kind of grace in realizing that the human form, in its stillness, mirrors the wider patterns of nature. The skeleton stands like the trunk of a tree, strong yet flexible, rising upward in alignment. The joints are the branches, bending and turning with the wind of movement, yet always returning to their central balance. The muscles, like leaves and vines, give shape and texture to this structure, surrounding it with life, and the nervous system, with its endless lines of connection, resembles the flow of sap through the tree, invisible yet vital, carrying energy and awareness from root to crown. The entire body, like the world around it, exists in a continuous cycle of activity and rest, of motion and stillness. In stillness, we can sense that this architecture is not purely physical. Beneath the structure of bone and tissue lies a deeper design, one that speaks of continuity, intelligence, and peace. The way the spine curves, the way the joints align, the way balance is maintained, all of it reflects a wisdom that predates thought. The body knows how to stand, how to move, how to return to stillness. It does not need instruction. It remembers. This remembrance is the quiet intelligence of life itself, woven into the very fibers of our being. As the body rests, the joints continue their unseen work. Synovial fluid circulates slowly, lubricating the spaces between bones. The cartilage absorbs moisture, replenishing itself after the day's movements. Ligaments release their tension, allowing the tissues to breathe. The still body becomes a place of restoration, a sanctuary where every part of the living architecture can return to balance. This is why deep rest feels so healing. why sleep restores not just energy but comfort. The joints, like the heart and lungs, depend on rhythm. They require both movement and pause, both use and reprieve, to remain whole. Reflection often arises naturally from such stillness. When movement ceases, the mind begins to observe not with judgment, but with calm attention. One becomes aware of the miracle of structure, of how everything within the body works together without conscious command. The heart beats, the breath flows, the joints rest yet remain, prepared. In that awareness, there is wonder. The very act of being still reveals the depth of life's motion beneath the surface. It is as if one could hear the faint music of existence, the pulse that has been there since the first moment of life, continuing without pause. To understand the living architecture of the body is to recognize that stillness and movement are not opposites but companions. Movement is how the body expresses life. Stillness is how it preserves it. The two coexist in every moment. Even the simplest posture, standing, sitting, lying down, contains both. The joints, which once enabled grand gestures and daily tasks, now serve as the anchors of rest. They hold the body with gentle precision, maintaining the structure that allows the mind to drift and the spirit to settle. This balance between firmness and surrender is what makes the human body not merely functional, but beautiful. As we age, stillness becomes not only necessary but profound. The fast, unthinking motions of youth give way to slower, more deliberate gestures, each one a conversation with gravity and time. The joints, though perhaps less flexible, grow wiser in their restraint. They no longer seek extremes of motion but the peace of balance. In this way, the body teaches us something about living, that there is strength in softness, wisdom in slowness, and beauty in simplicity. The still body, resting in its natural architecture, becomes a portrait of peace. When one finally lies down at the end of the day, the body finds its truest form of stillness. The joints align gently, the muscles release their grip, the breath becomes rhythmic. In that moment, the body and mind return to unity. The living architecture within all the bones, the ligaments, the cartilage, the endless flow of fluids, continues its quiet work of preservation. The motion that has carried us through the day subsides into calm, yet the life within never ceases. Like the movement of tides beneath a tranquil sea, to reflect upon this is to feel gratitude for the body that carries us, for the joints that bend and bear, for the silent systems that sustain motion and rest alike. Each movement we have ever made, every gesture, every step, has passed through this living structure. It has served without complaint, adapted without question, endured without thanks, and yet it continues steadfast, balanced, alive. In the end, the study of the joints and their workings leads not only to understanding but to reverence. The human body, in its stillness and motion, is a miracle of design. It is both fragile and enduring, simple and profound. The joints, those quiet intersections of life and structure, embody that truth perfectly. They remind us that motion and stillness are not merely physical states, but expressions of life itself, always moving, always resting, always whole. In the still body lies the endless rhythm of existence, and in that rhythm, the quiet assurance that life, in all its motion and calm, continues without end.